here are in first year? You just came in like during January first year. Okay, cool. We got a bunch of you. All right. So these are the people that you all who have been here before need to talk to, so that you can convince them to stay here. Okay. So we see them meeting after meeting. Okay. To get started, so usually the way these things go is that for those of you who don't know, so usually I do the announcements. And then we have certain segments. So we start off with a rapid fire news roundup. Then we do a project den, which we'll be doing today, or a feature story where we discuss together sort of like a news story.
You should introduce yourself too.
Yeah, I'll do that, I promise. Then we typically finish off with like a guest speaker. If we don't have a guest speaker, we do sort of like a CTF get together where we solve challenges. And then we have workshops that we do sort of throughout the year. And then we have our big competition, which is the ISSessions CTF, and I'll talk about it a little bit later. For those of you who don't know me, my name is Louis. I'm the president of ISSessions. We're also joined today by John. John is our webmaster. Webmaster. And then, So, to start with the announcements.
Oh my goodness.
All right. Happy New Year. Yay. Sorry, a little late. And again, welcome to our January 1st years. Just so we do this like right now, so and then whoever is here from that first year cohort that came in January, you can also add in your classmates. If you go to our website, which is ISSessions.ca, if you just want to go on your phone right now or on your laptop, there's a link to our Discord channel. If you want to join it right now, I would really appreciate that. And then once you're in there, you should all have permission to invite people into it as well. So make sure you put that. So if you have like a Discord server right now that's set up for your class, please add on ISSessions. Put a link for ISSessions on there. And I would actually also really appreciate if one of you, if you do have a Discord, come to me and let me know about it, and then I can add myself in. So I can also post announcements in there. I've been doing it with all the other years, and it's been really effective. Okay? So thank you so much. Yeah.
A bunch of the new wave of first years have joined the existing first year Discord. So if you guys haven't joined it yet, there's also a specific Discord for first years, which a bunch of your classmates have already joined.
Okay, perfect. Yeah. So if you're also in that Discord, if you don't mind sharing the link with them, I would really appreciate that. So first announcement. So we have a new workshop format this semester. And so basically, I heard two things from how we were doing it last semester that people were not happy about. One thing that I was really happy about to hear was that the actual quality of the workshops was very good, but that maybe the pace was a little bit too fast, so we were doing a few too many things in quick succession, so we're going to change that this semester and stay on sort of a 2-week track. And then the other thing is that there was sort of like a lack of communication as to whether this was a beginner workshop and an advanced workshop, and sort of how big is that gap that you would need to have in order for you to participate in that workshop and get something out of it. So this semester we're going to introduce tracks. So we're going to have 2 workshop days, which are going to have a list of workshops in them. And then there's going to be 2 tracks, a beginner track and an advanced track. And essentially, if you're like in first and second year, you probably should go to the beginner track. If you're in third and fourth year, you probably should go into the advanced track. I say probably because if you really want to do the advanced track, I'm not going to stop you. And then there might be a workshop that you want to go to in the beginner track, right? You might not want to do the advanced workshop when you're in third year and fourth year. That's totally cool too. But it's just that doing it this way will give you maybe a little bit more clarity as to what you should be aiming for. Okay, so hopefully that'll happen. What are our workshops? Our workshop day number 1 is going to be February 8th, 2020, so please save the date. In the beginner track, there's going to be an intro to soldering by your program director, Nicholas Johnston. And there's also going to be a crypto behind cryptocurrency workshop by Kiefer Wiseman, who's in the room right now. And then we're going to have an advanced track by Lee Kagan, which is building command and control servers. So they're all really, really cool workshops. I think the soldering workshop was like really popular last year. You get to make like a badge, I think.
Yeah, it's a little blinky badge.
A blinky badge, yeah. Crypto behind cryptocurrency. So you're going to be, learning how to write like a very simple crypto miner. You're going to be learning how to send digitally signed messages to each other. So if that's something that interests you, make sure to go. For the command and control servers, this one's actually like a really, really cool workshop. Lee's actually, so if, for you who don't know Lee Kagan, he's the organizer of C3X. I think he works for Norton Security. He's also the founder of Red Black Security, and now he is the head of DerbyConf Toronto. So he's like a really big guy in the industry here in Toronto. He's very well known. He's going to be delivering this workshop to us for free, but he actually is going to be turning this into like a training that he's going to be offering for money. So really, really good opportunity to go there. It's going to be a full day workshop. Actually, one thing that I forgot to mention, so you can't go to the advanced track and the beginner track. You can only go to one of them. Okay? So I know that introduces, maybe you really wanted to go to Lee's, or maybe you really wanted to go to something else, but it's just doing it this way will give us more time to prepare, and the quality of the workshops will go up. So there has to be a sacrifice to be made there. And then the second announcement, so I've been talking about this forever, but there's our CTF, and again, for those of you who don't know what a CTF is, it's essentially Calculify competition is a bunch of cybersecurity challenges that you get to solve, and then once you solve them, you get a flag to exchange for points. CTFs are like used all over the industry at like DEF CON and Black Hat, and every big industry conference has one, and it's something that employers look for on a resume. Whenever you're going to be applying for that, if you're not applying right now for co-op. The date for that is March 14, 2020, and it's going to be at the Trend Micro office in downtown Toronto. Okay, so I'm just going to give you the date for now, but you'll be hearing a lot more about it, and I'll be going to classes and a whole bunch of things to talk about this. Okay. Any questions? Okay, cool. All right, and let's move on to, oh, sorry, one more announcement. So I'm looking for speakers for our Project 10 segment, where you get to present like a project that you worked on, like a little mini project, or maybe a bunch of projects. And then I'm looking for guest speakers as well. You're going to see like the Project 10 segment today with Nick, and then you're going to see our guest speaker segment today with Alana. So definitely looking for them. You can reach out to me at Luann on the Discord, or at Pumpkin, that's Steffi, or directly to Rick. So that's it for announcements, and on to the news roundup with Nicholas Jones.
Cool. Thanks. Hi, everyone. Hope you're all good and stuff. So we haven't done news since, like the end of November. So there's like a metric buttload of news to go through. So I'm just going to kind of just talk headlines real quick. Anything that's really important I'll stop at for a couple of minutes. But really, I have like a lot of stories. Oh wait, and I'm supposed to be good now, but actually timing myself so that we don't go overboard with news. See, look, I'm starting the timer. See, you're welcome. Let me actually set this up. Nice. Oh my goodness, I've already lost like 10 seconds. Okay, cool. So, we get concerned when bad people on the internet start targeting things like infrastructure systems, like industrial control and public utilities and stuff like that. So it turned out that like back in August, an attacking group was going after a bunch of utilities like power grid and stuff like that in the US, and the FBI had been investigating it, and people are just learning about this, or were learning about it sort of at the end of November. So that's kind of interesting. I'm not going to get into that one in more detail, also because I just don't have a subscription to the New York or the Wall Street Journal, so whatever, we're just going to deal with that. Other stuff, Facebook said a Chinese company compromised users with malware and then ran ads using their accounts. Okay, that's just a thing that happens. Keep in mind that any account you have on any service can be monetized by some entity that wants to, right? That's the whole idea behind this. You have lots of accounts on lots of services, and if somebody can take that over and start pushing out spam and advertising and whatever, they're gonna do that. Fileless malware. We've had that on PCs and stuff for a long time, and then someone went and wrote one for Mac. So it's just to show you that there's really no difference between the platforms anymore. What you can do on one, you can do on the other. If you're not sure what fileless malware means, it basically means you get a piece of malicious software on your computer that doesn't actually have a file. There is no file that lives on your hard drive. Basically, when it attacks you, it injects itself directly into memory. And people that do forensics hate that, because if I take a copy of your hard drive, it's not going to be there. I have to somehow take a copy of live active memory on your computer to get that back. So yeah, that's the thing that we should be concerned about. You'll learn about that. IBM said, oh my goodness, they found a new strain of malware that allegedly has been authored by Iran that basically just wipes hard drives. So that's not great. Kind of data destroying malware like that has been around for a long time. I guess this is just like the opposite of crypto ransomware kind of stuff, but whatever. It's out there. It's dangerous. Make sure you have backups for all your stuff because sometimes you can just get a virus and it just blows everything away. So that's not good. Really cool piece from Bloomberg. Oh my goodness, everybody wants me to sign up for their stuff. About a user who basically took over the Mirai botnet. The Mirai botnet is a large collection of infected machines, mostly IoT devices like cameras and stuff like that. And someone used that large botnet to basically take down an entire country's internet by bombarding them with traffic and doing other stuff to screw up their internet. It's interesting because now we live in the days of what we call the asymmetric threat actor, which is someone like this, someone that maybe doesn't work for a country or a government or something like that, but one person has the ability to impact an entire country because of the way the internet works. It's kind of scary. This is not something that we have had before in the world, right? Normally when one country wanted to do something bad to another, you had to have a whole country with a whole army. But now, one person that can control something like a botnet has the ability to impact a whole country. That's the kind of the key takeaway here and something to consider. Hackers steal data for 15 million patients and then sell it back to lab that lost it. Canadian content, that was Life Labs. Yikes. Which is unfortunate because some of our alumni and our friends and family and stuff work at Life Labs. Oops. But whatever, hey, it happens. Interesting though that the person was able to negotiate with the attacker to get the data back and not have it dumped as part of a large data breach, which is awesome because then you would all find out how my cholesterol is and I don't want that. So that's cool. I'm glad that they got the data back and they now have a new CISO in place who's hopefully going to prevent stuff like that in the future. Looking at you, Mike. U.S. Coast Guard says Ryuk ransomware took down maritime facility. Again, just more industrial control system, large systems getting taken down by malware. It's not gone. It's still dealing with stuff. That's not great. This one, which has a sick logo, thank you, Wall Street Journal. Ghost in the Cloud inside China's major corporate hack. This one's just a deep dive on corporate espionage. It's a thing that China likes to do and have been doing for a long time. But this one just kind of goes into more detail. There's a couple other articles out there if you want to actually read it and not subscribe to the Wall Street Journal. Mostly it just talks about how some of their APT groups work and getting into a company and sitting there and siphoning off interesting research and data that they can then turn around and monetize. Yeah, it's interesting for some of us that used to read cyberpunk novels in the 80s when this was mythical stuff that happened between mega corporations and countries where people would hack other people and steal their research data. That used to be science fiction, right? It's not now. This is a thing that happens in our world. So cool if some of you go to work for some of these companies and that's going to be your day when stuff like that happens. Cool. An IoT camera company leaked the emails of 2.4 million users. It's not even, this is such a tiny blip on our data breach radar these days, but hey, it's still worth mentioning. It happened. Oil and gas APT pivots to US power plants. Basically what this means is an APT, if you don't know, is what we call an advanced persistent threat. Typically it's a hacker group sponsored by some country that gets in somewhere, they dig in, and they cause shit. They either steal data, they disable machines, whatever. But they're allegedly quite advanced. And apparently there was this one group that was going after the oil and gas industry, but they have now moved and changed targets to attacking US power plants, whether that be nuclear, hydro, or whatever. It's always interesting to see when groups like this change tactics. It suggests maybe there's something going on in the world geopolitically, or maybe they just found vulnerabilities in power plants. I don't know. But it's APT Group 33. I don't know any of the other details about them, but you can go and look them up and find out maybe which country they're from and stuff like that. Is it?
It says the third.
Oh, is it the third thing? Oh yeah, Iran linked. Not necessarily, just they think, right? Because nobody ever actually owns up to actually being an APT group, right? It's always, we think it could be this country. Pardon me? We can do a whole talk on attribution one day. It's interesting the way that we insinuate stuff, but yeah, we'll talk about that someday when we have more time. This one's just funny. IT exec sets up fake biz, uses it to bill his boss $6 million for phantom gear, as in pretend hardware, gets caught by Microsoft Word metadata, and now is potentially up for 20 years because of fraud. These kinds of scams actually happen a lot because of how bizarre and intricate procurement and purchasing processes are at a lot of companies. It happened to Facebook, it happened to Google. They got taken for millions because people basically sent them like pretend invoices for hardware they never bought. And these companies, just because they're so automated and rigid, just pay the invoices. And every now and then people will just get caught, like maybe you left the author name in the Word doc for the invoice. Yeah. Which, by the way, is something I used to use to catch cheaters all the time. It was amazing when I would open up a Word doc from one student and the author name was the other student's username. I'm like, oh, that's where that came from. Forensics, it's a useful skill. Banning strong encryption does not mean catching criminals. It only makes you less safe from them. There's another push on by some random law enforcement agency that happens probably every 6 months at this point to try to get us to stop using strong encryption or to outlaw it or to make it difficult for people to use, for regular citizens to use strong encryption tools because they want to be able to decrypt and read your data, typically in pursuit of a law enforcement investigation. And the pushback is always saying, well, if I have to use weak crypto, then I'm not just vulnerable to like police, I'm vulnerable to any malicious entity that would want to decrypt my stuff. So it has been a long back and forth fight between the information security industry and governments and law enforcement on should we have strong crypto or not. Obviously, most people here are in favor of strong crypto for individuals. Apparently, the California driver motor vehicle agency makes a lot of money selling drivers' personal info to ad agencies. That's crazy. Hopefully the new California privacy legislation is going to shut that down. That's just terrifying. Imagine, who knows if it's happening with some of our agencies that handle this data. I would be a little bit concerned if, I had to go get a driver's license and they're turning around and selling that data to people. If they're gonna, I would at least appreciate a cut of that.
We could have just trust the liberals to keep losing our census and
Yeah, but they're not even selling it. They're just losing it. At least, the DMV knows how to, turn a profit on this. But again, oh, that sucks. Apple and Google remind you about location privacy, but don't forget your wireless carrier. Cool. So yeah, we know that all the apps on our phone that we, have installed can potentially track us, track our location, even if you have location services turned off. The key takeaway here, though, is in addition to that, there's another entity that always knows where you are. It's not Santa, it's your wireless carrier, be that Bell or Rogers or whomever, because really you connect to their towers, so they know where you're connected, right? They know where you're going to be. And in the past, some carriers have also sold this data, or they have handed it over for investigative reasons, for lawful law enforcement warrants and stuff like that. So just something to keep in mind. That's another entity that knows where you are. Amazon Ring, the doorbell thing with the camera on it, they were planning on building watch lists based on all the facial recognition data. So you would know if a thief came to your door, I guess, or something like that. That's terrifying. We don't like lists like this because then it typically turns into ways to segregate people and start applying prejudices and doing all kinds of racist stuff to them. So not great when stuff like that starts to happen. Also, if I'm just walking past your house and I'm out in public and your doorbell or whatever is taking my picture and adding me to a database of stuff, that's sketch. I didn't agree to that. Yes, I'm out in public and I don't necessarily have the same reasonable expectation of privacy, but that's sketchy. Homeland Security drops plans to expand airport face recognition scans to U.S. citizens. Cool. Good for them. That's nice, because the less our faces end up in databases, the better, especially given a story that we're going to see in a minute. FBI asked Sony, PlayStation, and Evernote to turn over things like chat logs, Evernote data on users who are allegedly selling cocaine. Again, just keep in mind, if your data is sitting up with some cloud service provider, no matter what service you're getting, they have to respond to lawful law enforcement search and seizure and data requests, right? So I used to use Evernote all the time for just keeping notes and writing stuff down. And, there is that potential risk that if you do a bad thing, please don't do bad things, but if you do, that data is subject to seizure by them versus me keeping a text file on my desktop of all my nefarious deals that hopefully is encrypted and they don't get. This was wild. This was a crazy piece of investigative journalism, basically on cell phone location tracking. And this company showed how they could basically track loads and loads and loads of people based on like open and available cell phone data, to the point where they even showed that they could tell you where like Trump was in the US based on data that they had available to them that they could find. It is a wild article, totally worth a read. Again, we post a Pastebin link right to the news. Just go read this about knowing where people are and what you can infer based on where other people are as well. It's crazy. Also neat. I forget. Maybe. We can go back and double check. It's been a while because that was at the beginning of December, so I'm gonna be honest, my memory doesn't go back that far. Oh, hey, that Ring list that Amazon was building, also Ring had a data breach. So cool. Now we have all that data as well. Cool. So yeah, just whatever. Data breaches happen. Here, so massive errors found in facial recognition tech, US study. Cool, so it turns out facial recognition isn't perfect. Apparently in a lot of instances it's like really bad too. It's like 80-20 false positives to actual identifications in some instances. So yeah, we have all this cool facial recognition that's supposed to build these profiles and databases, but it turns out that like 4 out of 5 times it's wrong. So I don't know, make from that what you will. A lot of that is based on your training data too. So if you like train these systems only with white people, it's going to be bad at identifying or like applying accurate measurements to anybody that's not a white person. And we've seen that with all kinds of like scanning devices and stuff in the past. Cloudflare exposes millions of child tracking smartwatches. Oh my goodness, stop buying tracking stuff for your children. So yeah, there's like these cool kids smartwatches, right? And it's meant to help the parents, you know, GPS, know where they are and stuff like that. But if it's all pushing that data up to some cloud provider and the cloud provider has vulnerabilities and people can go and find all that data, that turns into like a bad person's like Christmas present, because now they have ways of finding and tracking kids, which is horrible. Which, yeah, just don't buy that stuff for children. Facebook separates security tool from friend suggestions, citing privacy overhaul. So people got mad when they found out that, you know, when you give Facebook a phone number to use as your second factor for authentication, so you know, like you enter your username, your password, and then it texts you a number that you type in to make your login a little more secure. Allegedly, they were only supposed to use your phone number for that login phase, only for security reasons. But then they started like looking at the phone numbers people provided and going, hey, you might know this person because they have the similar phone number as you. They weren't supposed to do that. They did. Yeah. Apparently, they're going to undo that, which is good, allegedly. Oh, no. Oh yeah, this was crazy. So the Epilepsy Foundation was targeted with what they call a mass strobe cyber attack. Basically, all of their users, or many of their users, had messages pushed out to their user base with basically like light video segments that would cause seizures in people with epilepsy. That's horrible. That's awful. And if we want to like step back for a second and think we're now in an age where, again, your asymmetric threat actor, one person has the ability to now cause not just like technical complications for a large number of people, but actual physical harm or injury to a large number of people. Wild. That is the future that we live in right now. Facebook fails to convince lawmakers it needs to track all your location at all times. Cool, good, awesome. They don't need to track my location at all times or ever, because I don't want that. And it's nice to see that lawmakers are starting to side more with privacy on stuff like that and taking that seriously. That's wonderful. Apple accused of crackdown on jailbreaking. Not a fan. Never owned an Apple, never into the whole jailbreak thing, but I mean, if I buy the hardware, I should be allowed to do whatever I damn well please with it. And when companies start to do stuff like that, I don't like that. That's just me, though. Maybe you feel differently. The California Consumer Privacy Act officially takes effect. That was January 1st, 2020. You probably noticed you got a whole ton of emails from all the services you subscribe to saying, hey, we're updating our privacy policy. Probably around the turn of the new year. That's because everybody decided, well, that's the strictest privacy law in like North America. So most organizations decided we're just going to apply that standard to all of our users because it's easier than trying to figure out who's from California and who's not.
What happened with Europe, basically?
Yeah, when GDPR happened in Europe, they did the same thing. Basically started treating everybody as though they were European citizens. Solid. Right. Anyways, so that legislation is probably worth a browse through. It basically has all kinds of information on things like right to be forgotten, when and how and why you're allowed to collect data, if the user's allowed to request that it be deleted, which is one of the coolest parts of that law. Right? I can say, hey, yo, you company, you have info on me. I don't want you to have info anymore. That's nice. Within reason. Oh yeah, back to Ring. So they wanted to make these databases of people, then they lost a bunch of data, then a bunch of employees got fired for basically spying on the camera data, right? A thing to think about when it comes to all the IoT stuff. Again, you're pushing your data up to some cloud product provider or whatever. Even if we make these things really secure and we can't hack into them, there's always still that human factor, right? There might be a person working at these companies that has access to that data that's just going to sit there and watch these video feeds, and that's true of any kind of technology product like that. Oh, neat. Apparently my clicker actually goes like down the browser. That's neat. Didn't know that. Google boots security camera maker from Nest Hub after private images go public. This was Xiaomi, I think, if that's how you say it, or Xiaomi. Xiaomi? Thanks. I don't know how to say words. Yeah, so they had bad security and people's camera pictures got out there. So they were like, no, you can't use our platform anymore because we want to care about privacy. That's cool. It's just the register being angry. Why is 22 gigabyte database containing 56 million users' personal details sitting on an open internet using Chinese IP addresses? Seriously, why? I don't know. This is the world we live in. If at first you don't succeed, pry again. Feds once again demand Apple unlock encrypted iPhones in yet another terrorism case. This happened a few years ago. And basically the FBI was saying, hey, you need to use exploits or whatever to help us get into locked iPhones because we can't solve crimes if we can't get into iPhones. There's a lot of pushback from the security community on that because to allow them to get into stuff like that, it would require putting backdoors in crypto, which we don't do.
Well, they have their own way to get around, you put a whole bunch of VMs for an iPhone, just start cracking and
Allegedly, yes, allegedly. But normally, when there's kind of an overlap, right? When there's a new version of the iPhone, and it takes them a while to figure that out. So if people have brand new stuff, they can't get into it right away, typically. What if everyone just said nah to tracking? Privacy is nearly dead, but we're not even close to getting over it. There's more a think piece, but it's something to consider, right? Why are we all cool with being tracked and having all this stuff that tracks us? I don't know. We shouldn't be. So maybe opt out of things when you have the ability to. HackerOne, which is a bug bounty website. Basically, you find bugs in software, you send it to them, and they pay you. That's in a nutshell. Let's outside hacker read customers' private bug reports, which is not great. So someone was able to get into their internals and read all of the private bug submissions for a lot of companies. That would give one person lots and lots and lots of vulnerabilities and maybe exploits that they could either sell or use to get in and do stuff. So that's not great. It's kind of hitting the treasure trove if you're a bad guy. Hackers find ways around a years-old Microsoft Outlook fix. Okay, so basically, sometimes patches aren't perfect. We tell people patch and update your software. That's cool. A lot of times it solves problems, but sometimes we'll patch something and maybe we don't do it the right way. Right? We'll think of a fix for a problem we have in code. We think of some kind of a workaround. We put it out there and we realize, oh, I didn't think of all the possible cases or all of the ways that this could have been interpreted. So it kind of undoes the patch. We've seen this with other patches that get rushed out. I think it was the shell shock vulnerability from a couple of years ago. They pushed out a patch for that real quick and it didn't quite work. So they had to push out another patch. Lots of Android devices and apps for Android are encrypting things now. This is actually not a horrible story for once. A lot more apps are starting to adopt TLS encryption by default by sending data from your phone up to wherever the app talks to. That's nice. That's good progress. We want all the things to be encrypted all the time. So cool. Oh my God, I'm 2 minutes over. Apparently, so Caterpillar that makes backhoes and stuff, they also make padlocks, but apparently all the keys are the same. Awesome. This was discovered by a lockpick expert that's called the Lockpicking Lawyer on YouTube, and there's a video of him opening this lock with a bunch of different keys. Loving that happens.
But there was an intentional reason for it.
Yeah. I mean, for recovery reasons and backups and keys and stuff, but it's just a thing that maybe more people should be aware of, I think. Yeah. Big game ransomware being delivered to organizations via Pulse Secure VPN. That's cool. So you have a security product, and I'm using it to push malware into your environment because your security product is insecure. We have this principle in security that says security tools are not necessarily secure tools, right? Just because someone can make a thing that does security doesn't mean the thing I made is secure. So just be wary of that when you deploy and put stuff into your environment. That thing itself might not necessarily be secure. Exploit fully breaks SHA-1, lowers the attack bar. Okay, so SHA-1 is a really popular hash algorithm, and basically people found a way to like crack that hash algorithm faster than we have before in a way that we can like determine, you know, the actual key or the original value in like less than the lifespan of the universe. That's scary. We need to start forcing everybody to use stronger hash algorithms like SHA-512 and all that kind of stuff. Same article again, the register just has a better title for it because they do alliteration well. Security, shaman, shame, SHA-1 standard, crucial, confirm crucial collisions criteria. Oh my god, I love the register. WebEx, which is a thing that a lot of people use for like online conferencing, had a remote code execution bug, meaning I could like just run stuff on your computer if you were using this certain version of WebEx, and I got you to like go to a link. So that's not great. Patch stuff if you use that. Windows 7 will be end of life on January 14th, meaning just no more updates, and we're going to stop supporting it. Cool. A lot of organizations still use Windows 7.
I wonder if it's going to be like a huge rise in ransomware targeting Windows 7 after the end of life. Like, is it like exploits being like held back because they know their end of life is coming very soon?
Probably, because so usually when Microsoft end of life's a product and there's still vulnerabilities or issues in it, sometimes there's ways to kind of get them patched, but if they don't, then we call those vulnerabilities or those exploits forever day vulnerabilities because they're never going to get patched. They will just live there forever. So yeah, you're probably right. We might see some of that. Apparently TikTok is insecure. Who knew? Like any software product out there, it's going to have vulnerabilities. Honestly, this is in there because of the register title. Again, TikTok on the clock and hacking won't stop. Just way better. Way better. I love the register. This one was like a roundup article of just random stuff. The Rowhammer exploit, which is where if I throw code at you fast enough, I can control the contents of RAM without actually caring about what the code was that I ran. But we can use that now to target FPGAs, which are field programmable gate arrays, which are like custom hardware devices that do stuff really, really fast. Oftentimes like your firewalls, certain types of network traffic analysis equipment, they use FPGAs because they need to process data very linearly, but very, very, very quickly. We use FPGAs for stuff like that. Apparently RSA, the organization, might be up for sale. And there's just more stuff. Oh yeah, apparently Tesla vehicle's Wi-Fi stack was vulnerable to some things. So if you knew someone with a Tesla, you could like hack their Wi-Fi and then, I don't know, play with their entertainment system or something. Cisco stuff had bugs in it. They patched it. That's important for anybody that does networking because, oh my goodness, patch your network hardware, which is a thing that maybe not everybody does all the time because it's like kind of there in a closet out of the way, but oh my goodness, we need to patch it. Department of Homeland Security says, hey, other agencies, you need to have vulnerability policies, like vulnerability disclosure policies or usage policies. That's cool. I like when they put regulations on agencies that talk about vulnerabilities. Really cool. Apparently that site couldn't be reached. Oh my goodness, yeah, the Tories, which is the Conservative Party in the UK, they had a bit of a data breach because they were using WhatsApp and some of their communications got out. So they're like, oh, we're all going to use Signal now, which is, I mean, I like when people use Signal, maybe not them, but whatever. Politics aside, it's nice when people switch to Signal because it is a secure end-to-end SMS and messaging app. So it's just neat when you hear of like an entire organization all deciding to switch over to Signal. I forget what that one was about. I don't know. It said White House and it said cyber weapons, so I put it up there. Go read it. It's in the thing. So Microsoft is really good at tracking down like these big organized online crime groups and just taking them down either through like attacking their infrastructure or getting their infrastructure shut down, sometimes finding some of them, taking them to court. So good for Microsoft for kind of helping the internet as a whole be safer and more gooder. Forget what that one was about, honestly, and I'm out of time, so whatever. A credit card processor in the UK got fined a boatload of money for having bad security practices that let a whole bunch of people's payment card data get out there. So good on the fine, bad on the data breach. Google's Project Zero used to have a thing about like when they would talk about the exploits, and now they're saying it's not great if we like drop this thing right after a vulnerability gets patched, we're going to like stick to our 90-day rule, I think. So that's good. Oh, that was the end of the news. Sweet. Whew. All right. Let's give like a thank you. That's pretty sweet. Maybe let's pause for 30 seconds so I can catch my breath, because then I have to do another talk on OWASP IoT Top 10. So just give me like a half a minute to catch my breath. Please and thank you. I'm going to make sure the stream is still working, because this is about around usually where the stream dies. Hey, it's still working. Oh, no. YouTube says there's no audio on the stream. Can anybody confirm that? Oh, really? When was that message? When was that message? Really? No. Because that one says stream health excellent. Maybe I broke the resolution. Oh, cool. I need to live like, I should do like a mini 5-minute on the day just to make sure everything's still. The Twitter, I tweeted the link on Twitter. I just didn't post it in Discord. Okay, I caught my breath, so I guess I can do this now. Although, have you seen our other guest speaker? Have you heard any word from our other guest speaker? Are they potentially unrelated? Yeah, that's cool. Yeah, that's cool. I'll just make sure that.
I really wanted to see your talk.
No, it's fine because I have to record this because I promised some people that I would, so I'm gonna do that.
I'm gonna tell her that she's missing out.
Yeah, totally.
Don't worry, we'll just play the tablet.
Yeah. Okay, hi again. So this is like a redo of a talk that I did at Toronto's OWASP meetup in December, OWASP being the Open Web Application Security Project. I did a talk there on their IoT top 10 list. OWASP publishes these top 10 lists of like web app vulnerabilities, and I think it was 2018 or 2017 was their first IoT top 10. Well, because they realized that the vulnerabilities in connected devices in our homes are slightly different than the vulnerabilities that we see in popular web apps. And I think they wanted to address that with a list of common things. So I put together this talk, which is supposed to be an introduction to that list, and then trying to figure out where do these problems come from. And you'll see the disaster that was my attempt. So normally for the OWASP audience, they wouldn't know who I was. But you do. But whatever, I'm going to introduce myself again. Hi, I'm Nick. I run the security degree. Hi, Wes. I run the security degree at Sheridan College. And before that, I did forensics and incident response, and I was a pen tester, and I was a developer. And I used to be a cook a long, long time ago, but whatever. I do stuff on Twitter. I also like to make things. like electronics and stuff like that, and I like to learn about electronics. That's why the security and the electronics bit mushed together, and I decided I should do a talk. So what is the talk going to be about? Well, why did I want to do this? Then an intro to the top 10. Then my thing that started out as a case study that turned into oh my god, I have to get this thing to work, and that finally just became, this was an experiment in making an IoT product. Things that I learned, some suggestions around security, and then in theory Q&A. Stuff that I don't want to mention, weird stuff that involves nation states, like people injecting weird chips into your manufacturing chain on the assembly line. That questionable Bloomberg article from last year talked about. Other stuff, I wanted to focus on consumer products, not stuff we see in industrial control systems and in utilities or the medical industry or the military. They have their own IoT problems. I just wanted to look at the smart fridge you have in your house, stuff like that. I also don't want to talk about the impact of the problems with these things, because we know what can go wrong if I have a rogue Wi-Fi toaster. I just wanted to understand, why is the Wi-Fi toaster such a crap product to start with? We have lots of things that have Wi-Fi in them now, right? Everything from doorbells and plugs and whatever the hell. This is to thermostats, to yes, toasters, or your smart home assistants, or locks, or honestly, I have no idea. I found this picture. I didn't even read the product posting. I was just there's eggs in an egg thing, and someone's obviously doing a Wi-Fi with it and putting this picture in the presentation. Does it let me know how many eggs are left? I do not know. Evidently, though, eggs have Wi-Fi. So anyways, but I just Googled smart home, or searched for smart home on Amazon, and that's how many hits I got. So there's a lot of stuff, right, that we sell that has Wi-Fi in it. And we do it because we like convenience, right? I want to be able to turn my lights on with my smartphone, but there's a cost to that convenience. We have things like code execution, meaning, again, someone can run random programs in a smart plug that I have in my wall, or we have devices getting taken over and made part of botnets, or we have researchers showing that, seriously, they could man in the middle a Samsung smart fridge to then start doing stuff with it again, put it on a botnet, or spy on users, or just know the contents of my fridge. I don't know. But there's basically, we have these things, they are vulnerable. That means that these conveniences actually become threats to our, home in a way. So why did I want to talk about this as a problem? Honestly, there was a lot of talks at Black Hat the last 3 or 4 years about it. There's also been talks at all the other security conferences. I just listed the Black Hat ones because they have this cool little search feature on their website that gives you those numbers. I didn't want to have to go read through all the DEF CON things to find out which talks were about IoT. Also, OWASP released their IoT top 10 list in 2018, and I happen to like electronics and security, so I was this would be a cool thing to think about and talk about. But mostly, last year at Sector, which is the Toronto big Toronto-based security conference, Lee Brotherston, who works for Ecobee, sorry, Lee, I usually say that wrong. He did a great talk on IoT security and an insider's perspective. And basically, Lee used to work in the general consulting InfoSec world, but then went to go work in-house at a IoT vendor, and talked a lot about some of the challenges that security faces on the inside of an organization. And it was really interesting because a lot of the stuff that we in information security usually say, oh, this is so easy to fix. He came up on stage and he explained, yeah, I used to say that too. But then I started working for one of these companies, and now I know why it's not so easy to fix. He had described a couple of things I'm going to touch on in the presentation, so I'm going to explain them real quick. First off, he said one of the problems is that you have things in places, meaning your ability to do asset inventory on all of your Wi-Fi devices is very difficult, right? Maybe I sell my product as the manufacturer, but maybe I also sold 1 million of my product to Canadian Tire, and another 1 million of my product to Walmart, and another 1 million of my product to Amazon. I don't know at any point in time which of those products are sold and which ones are not, which ones are plugged in at people's homes and which ones are sitting on shelves in warehouses. So from trying to understand how much of my user base got their most recent patch, how many of them are running outdated versions of the software, how many of them are actually connecting back home, you can't know that stuff. And that's a big challenge compared to in an organization where I know I have 200 employees who each have a laptop. I at least know how many devices should be connected and should be updated within a reasonable amount of time. This is a much harder problem. Also, the idea of identity and access management, right? With my own users, it's great. I can manage their credentials, I can enforce policy on them, I can do all that kind of stuff because they're my own users. But when I give you, when you buy a product from me or from one of my suppliers and you take it home and you plug it in, I have no authority over your network. I have no ability to enforce policy on you. I don't even know who you are. You might be a trustworthy entity. You might be an untrustworthy entity. I do not know these things, and that's a challenge. They also want low friction deployment. So I come home with my like smart fridge. I want it to work. I want it to do the smart things, and I don't want to spend like hours going through configuration menus, setting up like two-factor authentication for my fridge, for getting my fridge on like, you know, setting in, doing security config for my fridge, right? Marketing says no. I want people to go home, they plug it in, maybe they enter your Wi-Fi password, and that's it, right? Software supply chain. So we run embedded software on IoT stuff, and I mean, that basically means every IoT manufacturer becomes an operating system developer because they all have to maintain these tiny code bases that run on hardware, and that's challenging. A lot of hardware protections are not feasible for consumer grade IoT. So yeah, we can make it so that when you take the cover off something, like the chips inside like melt or blow up, or like they basically can't be used once someone tries to get into it. That stuff's really expensive. And that stuff can maybe be put into like $30,000 firewalls, but not into like a $5 plug that goes into my home. So I have to assume that basically someone will get physical access to the device and compromise it. There's also revenue challenges. He spent a big part of his talk talking about how like security's budget is structured in that they get so many pennies per product sold. Right? Because you also have to pay marketing, you have to pay advertising, you have to pay manufacturing, you have to pay research and development, and all that gets factored into how much money do we make off of one product. So everybody gets a few cents off of that. So try planning a security team, a security like budget off of that kind of a pricing model. It's very difficult. So that is sort of the background. The OWASP IoT top 10 list. So the most common vulnerabilities with IoT products are weak, guessable, or hard-coded passwords. This is such a common problem that there are entire websites devoted to like searching for default usernames and passwords for IoT products. Cool. So I just put in a IoT device, like Wago or maybe Belkin or whatever, and it would just show me, hey, if you want to like remotely connect to this thing, here's probably the default creds for it. Awesome. That's a really useful thing. So what do they mean by that? Easily brute forced, publicly available, unchangeable credentials. That is a big problem. How do you change credentials in something you can't even log into as an end user? So this is some of the challenges that they face for weak, guessable, or hard-coded passwords. Number 2, insecure network services. There are so many stories of lame IoT products that basically have Telnet or SSH or FTP just running on it for no reason. Like, why do I need to Telnet into my lights at home? I don't. There's no reason I would ever need to do that. I have a perfectly good app on my phone that I can use to change the color of the lights in my home. Why do they leave a Telnet server open and running on it? Probably because, well, reasons we'll talk about later, but basically lots of insecure services that leak data or could be used to compromise the device, take it over and use it as a botnet, stuff like that. We don't need those things. Number 3, insecure ecosystem interfaces. So if you have a smart device and it connects and talks to stuff in the cloud, or you can modify the device through a web browser, that basically means that you just have standard web application vulnerabilities. So this was like OWASP's nice way of tying into their regular top 10 list. So it's all the problems we typically see with web apps, like missing authentication or bad authentication. I don't know, weak encryption or no encryption at all, like bad data validation, all the standard stuff that goes wrong with software. You have all those problems in the IoT world as well, because your IoT devices talk to the cloud. Lack of secure update. Oh my goodness, so many challenges with updates on IoT devices. First off, you need to make it like updates easy and automated for IoT stuff, right? Because honestly, like who goes and intentionally updates their smart toaster or their smart television? Nobody. I think somebody pointed out, there was like a video on YouTube of one of the smart TVs, and there was they walked through the process for how to update the smart TV, and it was like 17 clicks through different menus and stuff, and nobody's going to be doing that, right? There's also problems about, like if I push out an update on an IoT product, it better work. Because if I push out an update and it bricks your device, you're never buying one of my products again. Because my software update broke your toaster and now your toaster doesn't work, or your thermostat, right? So like you kind of have like a one shot to get these updates right. So you can't do continuous updating that a lot of software companies do. A lot of them don't have rollback or anti-rollback mechanisms because you don't want people to be able to force old insecure code onto a device. The updates weren't encrypted in transit. So you can like man in the middle of the update and put backdoors in the code and stuff like that. So lots of problems and challenges around secure updates with embedded hardware and devices. There's a really cool article from some researchers at Carnegie Mellon University. They were looking at diagnostic tools for automobiles, and they found that the diagnostic tools, when they got updates, the updates were not cryptographically signed, they weren't encrypted as they were sent over the air, and they could basically make all kinds of malicious modifications to the diagnostic devices that would then compromise the car itself. So they have a paper up that you can read about that. It's interesting. Use of insecure or outdated components. Basically, you know, this just means bundling old insecure software in with my IoT software. So maybe I use an operating system, like an embedded operating system that's not secure. Maybe I designed all my products around a certain CPU or a certain microcontroller, and we find out later on that that chip is vulnerable to something. Well, tough luck. It's already in 3 million of my product. It's already out there. There's literally nothing I can do about that. So these problems, like Spectre and Meltdown and Heartbleed maybe, probably exist in a load of IoT products, and there's nothing we can do about it because you can't update that kind of stuff in that kind of situation. Privacy. Most IoT products are like, what's privacy? They basically don't encrypt data. They transmit data over unencrypted channels, things like that. The whole ecosystem lacks a lot of safeguards around privacy. And we might sometimes just say, hey, yo, throw encryption on it. You're fine. Once the data is encrypted, there's nothing that can happen. But unfortunately, even when you do the right thing, which is do the encryption, researchers at Cornell found that with a bunch of smart home devices, which were like thermostats and stuff like that, just metadata that they got from watching traffic was enough to leak data about the owner of that device. They could infer a lot of information about the people that had that device in their home just by looking at the metadata of the encrypted traffic. So that's a challenge. Insecure data transfer and storage. Yeah, there's just no encryption in these things. Apparently it's difficult to do crypto. One of the challenges, because in software it's kind of easy, but sometimes hardware makes it difficult to do crypto. So this chip that you see in the top right corner there, yeah, right, cool. The ESP8266H, which was a really, really popular microcontroller for a few years because it basically has a full TCP/IP, like 802.11 Wi-Fi stack built into this tiny little chip that you could get for like $2 a pop, or these days like $1 a pop on eBay and AliExpress and all the usual suspects. So a lot of people were making IoT products with this because, oh my god, it was a Wi-Fi chip for $1. And you could kind of custom build firmware for it, and there's sites like Node MCU builds, which would allow you to customize and build firmware for these things. And they ran some stats, and they found out that, I forget what year this was, 2017. In 60 days, they found about 13,000 plus custom firmware builds for the ESP8266 chip, and only 20% had SSL support, and 10% included the crypto module. So like, that's a lot of firmware and builds for these things that weren't doing encryption. That means lots of plain text web traffic. So I bet some fraction of those were prototype devices for products that went into production. Some chips just don't have hardware support for crypto, so you have to do it in software. And you use up a lot of the space on that chip if you dedicate some time for doing crypto in software. It's a challenge. I'm not saying they were wrong for doing that. It's just, it's a constraint that you have to deal with. Lack of device management. So there's no, that problem I mentioned where you have things in places and you don't know where they are. That's basically this problem. You don't really have a good idea of how many of your devices are connected, what their update status is, if they're working properly, because they're all over the place and they could be everywhere. The problem here is, though, is even when we know all that stuff, like if you take a regular computing environment, we as security professionals are really, really bad at standard asset inventory. So many organizations couldn't tell you the patch level and update level of their laptops. Turns out lots of people still track this kind of stuff in Excel. Lots only verify like device location and if they exist, like, you know, once a year, or some of them every 5 years. People spend a lot of time trying to get the asset inventory problem solved, and that's in regular IT environments where you know your employees, you know your assets. Never mind an IoT environment where you don't have control over any of this stuff. Insecure default settings. Yeah, these things ship with settings that no production system should ever have. For example, an FTP directory that's read, write, and execute by literally everybody. Web servers running as root, so if I compromise their web server, I've rooted the device. Like all this kind of amazing stuff. Basically, that's it. Probably like artifacts from development that were left over. And last, lack of physical hardening. Yeah, because securing things against physical attack is really costly, really expensive, and typically not within the budget for a standard consumer IoT product manufacturer. Maybe they put the sticker on it, and we all know how good that sticker is. They used to get away with it by doing things like not labeling debug and serial ports on PCBs and on boards and stuff like that. But now we have tools like the JTagulator and all kinds of other stuff that can allow us to identify all of these ports really, really easily. So yeah, we can't rely on security by obscurity for IoT devices, and hardware just does not work. So the experiment, I wanted to find out why do these 10 things keep happening in IoT devices all the time, because it's quite common that we see those problems. So I wanted to try to put myself in the situation of maybe some of these developers and product manufacturers. A couple of constraints, like I wanted to understand the pressures of getting to market really quickly and the compromises you make when you're trying to do that. I also wanted to pretend that I was unfamiliar with the IoT product development process. No problem there, because I wasn't. I've never made an IoT product before, so that was not going to be a problem. And lastly, I had to pretend that I was unfamiliar with secure software dev practices. So I got drunk. I don't know. I had to forget stuff, so that's what you do. I boiled it down to, fine, I'm going to try to make something in 24 hours to kind of simulate the rush of getting to market. So this was my scenario. My scenario being, it's after exams, and you go to the pub to celebrate being done exams. And when I was a student, we would go and we would get website drunk. Getting website drunk basically meant sitting around with your friends going, man, I hate school. I just want to come up with like $1 million website idea so I can stop doing this, right? And we would get drunk and talk about all kinds of ideas for that. I assume now people just go get IoT product drunk. They're like, hey, what can we stick Wi-Fi in that'll make us $1 million so we don't have to go to school anymore? So I was sitting there thinking about this, and I was like, oh, smart mirrors. Whenever I see a smart mirror project on like Hackaday or the internet or whatever, I friggin' love them. These are those mirrors where like they just have data so you can see yourself, but I also know what the weather's going to be that day or when like my next few trains are going to be and stuff, because I am not a together human being, and I don't think to look at that kind of stuff before I leave my home, right? So if I saw that in the mirror, like while I was combing my beard, amazing. I would know if it was going to rain that day, so I would know to grab an umbrella. I probably still wouldn't, but whatever, I can pretend that I would. So ultimately, all a smart mirror is a piece of like one-way, or yeah, what do we call those? One-way, two-way glass, whatever, with like a monitor strapped to the back of it. That's ultimately what these things are, because if the light source is close enough to the back of a one-way mirror, it will shine through. You will see it. So that's what a lot of these projects are. I found out later you can even just buy like a film that's reflective on one side and not on another. So you can get a piece of like acrylic or plexiglass or whatever and make that into a one-way mirror. That's neat. I didn't know that before. And a lot of them just have a simple computer strapped to it that's then making queries to some API on some website to gather that data. Really, though, that's what a smart mirror is. So here I was in the middle of my situation. I'm like, oh, okay, so other people are making smart mirrors, so I have to be first to market because I need sweet, sweet venture capital money so I can stop going to school. Turns out I had a friend that works in television, and they managed to get me a spot on one of those venture capital pitch shows, right? Unfortunately, Dragon's Den and Shark Tank don't do IoT stuff anymore, so I was going to be on Goose Roost, which is going to be amazing. This is a thing where they just like ding you off with a bell or they honk at you if your product sucks, right? So it was the start of the day, and I started thinking, what am I going to make? Well, I knew I was going to make a smart mirror. Obviously, I have to do the important stuff first, right? Like I have to come up with a cool product name. And after a bunch of dumb ideas, I came up with Brain Mirror. Not that that's any like less dumb, but that's what I thought. Then I have to like pay $10 to register a domain name, or if you're cheap like me, you just load your domain name into your etc. hosts file, and all your code will work, so that's fine. And then obviously you need to bake memes into your logo because you want to capture that youth market, so you're good, like you're ready to go, right? But before you do all that, then I was like, oh no, crap, I need requirements for this product. Like, what does it actually have to do? Because I have to put constraints on myself, right? We're trying to simulate a real world thing here. So at that point, it was probably like noon, because I took a long time trying to Photoshop the brain thing into the mirror. So like, I was like, okay, well, obviously it's got to be cheap. Nobody's going to shell out a lot of money for a smart mirror. I don't want people to have to pay subscription fees, because nobody's going to pay me a $5 a month subscription for their mirror. I wanted to try this low friction deployment thing, so it should be pretty easy to set up and configure as a regular user. I want it to be easy to use. And hopefully it should work. Like, I'm not great at code, so maybe not. So I went through my bin of dev boards to see what I had. Raspberry Pi Zero with Wi-Fi, cool. That'll probably be good. But ultimately, anything that'll do Wi-Fi and can run embedded Linux would work for a project like this. But I had one of these, and they're like $10, so that's fine. Here's my prototype, where I just took whiteboard marker and drew on my mirror, and this is kind of ultimately what I wanted to build. There's the Pi. And here's all my data readout with emojis, because why not? Right? That, by the way, is going to be featured on Netflix's Nailed It IoT edition, because that's like honestly best smart mirror you've ever seen. Right? Anyways, so the general solution for the project, I kind of sat around and thought, okay, so the Pi itself, because I got to get a user to connect to this thing and set Wi-Fi credentials. So the Pi was going to start up in access point mode. So it's just going to be like its own little Wi-Fi network that you could join, and it would ask you for stuff. Right? So the user would connect to that maybe with their phone or a laptop or whatever and enter the Wi-Fi details for their home. Right? Because otherwise, how would this thing know what your own Wi-Fi creds are? Then it should bounce you to like a login page where you can do this setup for your mirror, because you'd have to tell it, hey, what train schedule do I want to see? What city do I live in? So I can get the weather for it and stuff. So I'd have to figure out a way of getting your user to like a registration thing. But then I want to save all that data up in the cloud, because everything gets saved in the cloud. So I have to figure out how to do that. Then the device would basically reboot. The monitor should be in full screen mode with no buttons. It should go right to the web browser, right? Like I want to make this thing look really slick and smooth and stuff. I don't want to see no buttons, no nothing. And then basically at that point, the device is just on. It should be regularly pulling the internet for data that it's going to render in this display. Okay, so I had some challenges here because some of this stuff I had no idea how to do. Also, because at this point, I think I had like 8 hours left. So I abandoned some stuff that would have made this really good, but really time consuming to set up. And I just went with what I already kind of had running for some other projects. So there was no Amazon, there was no Docker, there was no like React for fancy looking front ends. There was like, I had some credit on DigitalOcean for my cloud servers. Obviously it was running on a Raspberry Pi, so I had to use Raspbian as the operating system. I know Python, and I know the Python web framework called Flask, cool. For data storage, I was going to try using Redis because I did not have time to make proper database tables, so screw it. I'll just throw everything into a Redis data store as JSON. If you don't know what those words are, that's fine. One day you'll know, and then you'll not like me for knowing those. The Raspberry Pi setup, first off. So I grabbed the latest operating system, which is Raspbian, so I downloaded that. And then what I had to do was make a copy of it onto an SD card, so I DD'd it over. That's fine, I'll give you these if you want to look at the commands. Then I booted the Raspberry Pi, I went through the standard Raspberry Pi install, added some extra Python packages and stuff like that. And then I shut down the card, or shut down the Raspberry Pi, and I made a copy of it. Because the goal here is I want to be able to make this thing ready for mass production. So I want to have an operating system that I can just flash onto millions of SD cards and plug into devices and make lots of money. So I wanted to have all the software preloaded. So I went through all the install for the Pi, and then I mounted the little image for this thing, and at that point I could copy all my code onto it, and then I could unmount it, and it would be ready to go. Okay. Now I could just kind of DD this thing onto lots of SD cards. Other stuff, I wanted this thing to basically boot with no password to the desktop and full screen the Chrome web browser with no buttons or nothing on it, right? I didn't know how to do that. So turns out you can make some configuration changes like this to the Raspberry Pi that will basically make it boot with no login prompt, no nothing, which was cool. So now you know how to do that. Then I wanted it, so this is the point where when someone first buys my mirror, right, and they plug it in, I need this thing to start up as its own Wi-Fi access point. And again, I had no idea how to do that. So apparently any code you put in, etc., rc.local will run every time the device turns on. Okay, because sometimes power will go out and you need to account for all this stuff. So I'm going to run a program. Basically, if it already has a text file called Wi-Fi creds, then I'm basically just going to go and run the regular mirror that you should see with all the cool data on it. So something that I learned, this. If you want to get basically like a screen of any kind to basically load with a web browser loaded with no buttons to have it go full screen, this is the command you can run. So Chromium or Chrome if you have Chrome. And then you can point it to the website that you want, and then you say start full screen and in -- kiosk mode, meaning there's not going to be no buttons, no nothing. That's the command. It'll basically just full screen a GUI app when you boot it into Pi or something, or any operating system. That's cool. Now I know how to do that. If there were no Wi-Fi creds, meaning this is the first time we're being plugged in, then I had to start a different app. So Mirror in one case, or in the other case, the Setup app. In Setup, it basically just threw this message up on the mirror, and it said, yo, you just plugged in this Wi-Fi mirror for the first time. Please go to this IP address. And I could hard code that. So the person could take out their phone or their laptop, go to that address, and go to /wireless. Or you had to connect to the network that it was broadcasting, and then you could go to /wireless. When you did that, there was a setup page, and it said, hey, what's your wireless network? What's your password? And you hit submit on that. right? And then it would send that down into the Raspberry Pi, which could then connect to your Wi-Fi network, and you were good to go. Here's how we would reply to that. So you send me a request to Wi-Fi. Don't worry about trying to read the code. It's fine. I would grab the SSID and the password, which we sent as part of this form right here. And I would spit back a message saying, hey, good job. And then it occurred to me that like if your phone was talking to this thing, I just turned off the access point and connected to your Wi-Fi. So then how does your phone know where to go? I was trying to figure that out, like how do I send a message to the phone before I disconnect and stuff like that, but I wouldn't know the new IP address. Like it was all kinds of problems. So I realized, oh wait, I still have a mirror. So I threw up this message on the mirror that said, hey, now I'm on your Wi-Fi network, so please just go to, and I would figure out the new IP of the machine and tell you to go to /config, and this would help you set up your mirror. So here's the config page. Basically, what's your username? What's your train station? And where are you going to go? And I don't know, themes, if I knew how to make themes. So you would fill out this form and you would submit it, and then bam, your mirror would be all configured and it should just start doing stuff. Here's the form. It would send this register form to the mirror's internal web server. And then here was the I had this thing called hidden, which was some kind of key that had a big long number. This was my attempt at security, basically by embedding some secret key into the form with no encryption. That's fine, whatever. I'm not going to go through this, but if you ever want to actually configure a Raspberry Pi or another device like that as a standalone Wi-Fi access point, here's the code that you do, or the commands you run to do that. So you just tell it to be an access point and to run DNS and stuff like that, the IP range you want. Then you can tell it, you know, what do you want the Wi-Fi network name to be, and all that kind of stuff. And then basically that will turn these devices into a standalone Wi-Fi network, which is kind of handy in some situations. Anyways, so imagine now the mirror is on your Wi-Fi, it's configured. Now we still need to like have data in the cloud somewhere. I want to store your user profile for the mirror so that if you, I don't know, move somewhere new and you set up the mirror again, it should download your profile data for you. So this is what you would run on your cloud provider. Basically SSH'd into a virtual machine that I had up in the cloud. I installed some stuff. I cloned my code repo. I installed the requirements, and then I just turned my mirror service into like a service that runs forever. That's basically all that did. What does the server actually do? This is all boilerplate code for getting a Python Flask app up and running, and there's also a shared secret key that keeps other people from using my service, which we saw in a form earlier. The device registration, all it does is it just takes all the data you sent me when you registered your device and it throws it into basically a Redis database. Don't worry if you don't know what that is. Basically, I just lump all that text, like your Go train station stop and whatever, and I just dump that into a storage mechanism up in the cloud somewhere. Here's the code that the mirror uses to retrieve data. Basically, every, what's that, like hour? Maybe hour? It asks the internet, yo, here's the secret key, and here's my username. Give me all that person's data, and then it draws it on the mirror. That's it. It just uses the same key as every other user and sends it a random username, and it will draw all the data on the mirror for me. I'm not actually going to show the draw data function because I didn't write it, because this was like 11:30 at this point. On the mirror, so like on the server side, I'm basically receiving your request to get mirror data. I'm checking to see that you have the same key as everybody else. And whatever username you sent me, I'm going to grab all their data and shoot it back to you. That's how it works. I realized I also had to add a software update feature because software updates are cool. So basically, once a week, the mirror will ping the cloud instance and it'll say, hey, here's what version of the code I have. And the cloud will say, okay, well, I have a newer version than that, so here's the new version. But basically the way it does that is it turns all the code into like plain text and just spits it back down the internet at you, and you receive that and you just write it into a file, and that's your software update. It works surprisingly well. It's insecure, like it's like Swiss cheese. It's so full of vulnerabilities, but whatever, it worked. And I wrote it in like 20 minutes, so I was really happy. At that point, I was like, okay, I've made the most insecure mirror ever because there was no actual encryption. Everybody had the same key. There were so many problems, but it was like the end of the day, and I had the basic functionality working, so I was like, good, fine, this is good enough to make my point. So kind of like what went wrong with this? First off, weak guessable or hard-coded passwords. Yeah, I had one of those. I had this like shared key that everybody knew. The idea was it just basically kept people that didn't have a mirror from talking to my service, but it wasn't very hard to figure out what this key was. This is one of the problems in IoT where we have untrusted connections the first time someone connects a new IoT device. Like, how do I know who you are? How do I know that you should be able to talk to my system? There apparently are protocols for doing this properly. I just didn't know them. And I thought, oh, maybe that's one of the problems that these developers have. Maybe they just don't know the right way of doing these first few steps to make sure that trusted entities are connecting right the first time. Insecure network services. Yeah, in my rush to do this, I forgot to turn off SSH to the little box, so anybody could SSH into my mirror. I actually never turned off that like local web server that you use to initially like register and connect to the device. Just forgot to turn it off, so that was always running. Why? Turns out, yeah, sometimes developers forget things and they just leave them in there. Things that were used to make development easy, they forget about it in the rush to finish the project, so that it gets left in there. Other things that went wrong, insecure ecosystem interfaces. Yeah, everything on the server side up in the cloud was insecure as heck. There was no real authentication or authorization. Everything was plain text. There was no encryption. I didn't do any data filtering at all. The output had all kinds of potential cross-site scripting vulnerabilities. It was C-surfable. Again, maybe people just didn't have the time. Maybe they had outdated notions of that. Of what, crypto overhead in hardware, although it's not really a problem anymore. So maybe that's the origin of those kinds of problems. Lack of secure update mechanism. Honestly, I'm just happy it worked at all. But yeah, maybe I just didn't know the easy way to solve that problem or the correct way to solve that problem. So it was kind of whatever the developer thought of for an update mechanism, and that's why there was no crypto. Privacy protection and data in transit and storage. So yeah, there was no encryption. I just didn't have time. There was other stuff I thought about too, like I could start pulling other people's configurations because it would accept whatever username I gave it. There's potential privacy implications in that. Didn't even think about that. I didn't build in any way for someone to delete their configuration information that was up on the cloud. That's in violation of a bunch of the new privacy legislation as well, so whatever. It's just, that's all I could figure out how to do. So the question is, would it be easy to fix these? Yeah, but the problem with making stuff that works is that the second it works, someone's going to push you to, okay, good, now we have to go to market, we have to sell it. You don't have time to go back and fix it and do it the right way. So I think one of the lessons here is always do it right the first time because there is nothing more permanent than a temporary fix. So I looked at what did all these problems I did have in common? Well, obviously the rapid pace of development was a problem. The product requirements around the low friction deployment, making it easy to use. And also just some of the protocols and security stuff I just didn't know off the top of my head, and that was a challenge. So I'm sure other people face those challenges as well. So those are some of my thoughts on what the actual root causes could be. What can we do about that as security people? Can we make ecosystems like server-side and cloud-side and operating system that are secure by default so that IoT developers just have to install this OS and it's ready to go? It does all the secure stuff by default? Yeah, sure. People should do that. It's probably a hard project, but whatever. So yeah, a secure base OS or even using container services like Docker might be cool. Can we start building libraries and frameworks that make some of these challenges really easy to solve? Like this problem of me connecting the first time or around managing user identities and stuff. Can we basically make that a function call? And then we've made it really easy for the developer. And finally, education and training. Obviously, people need more of that, so the IoT top 10 list is probably a good place to start. Anyways, that was it. I had an hour to do that last time, and Luai told me I had 20 minutes this time. So, yeah. Anyways, let's take a break for 5 minutes while our guest speaker gets set up, and then you come back and listen to a far more interesting talk. It's part of the bit. It's part of my shtick. It's cool. Yeah. Oh, okay. No worries. No worries. Yo. Do you want to record your thing? Mm-hmm. Do you want to stream or not?
Sure, yeah.
We always have to stream. Sure.
She did stream on that. If she didn't come in time, maybe we'll just stream the hack us on screen.
I'm mad.
Let's get out of the way. I haven't seen you in a decade.
It's been time.
Well, Nick, you lose weight again?
It's been pretty
Weight
late.
again?
We'll talk more when we're done.
Yeah, let's go to the bar. Are you coming to the bar after?
I'm heading over to college after, and I'm just heading back home after, so.
Oh, okay. To Collins. Okay. But yeah, we'll talk after. I like boot my laptop because there's no power in the power plugs. Nothing's changed at Sheridan, you know?
Sheridan what? We're talking about lots has changed.
Oh yeah, less power plugs work.
Lots
Like,
of plugs work.
usually at least the one beside you works.
Yeah, at least all the art students have iPads. Can't cram talk on permanent record.
What are you talking about? Just over here.
What are you
Put
talking?
pause on the stream. I don't know if that actually does anything. We'll find it.
No, everybody knows Sheridan's dirty secrets, so you know. Sorry.
What secrets? Which one secrets?
I'll elope to Russia just like Snowden did. Yeah. I really thought it was him. So good. Yeah. I was like, why is he not sitting with the rest of you guys? I was like, oh, that's why.
Yeah, I almost felt like this when he walked in. I was
Yeah, they get a lot of that.
no.
It's not,
Oh, yeah, because you're
not waved down randomly.
Well, it's good to see someone's carrying on the tradition.
How they make money.
Somebody's got to take one for the team.
Got the stickers, got the most of the way there.
Yeah.
See you there.
Are you going? I guess you're going afterwards, right?
Yeah, for sure.
Good.
Can I take this?
Oh, yes.
I just wanted to make sure.
Yeah, totally.
There's no confidential.
Micah.
Yes.
Yeah, but why don't we ask so we can like call ahead this or like despise us?
Just a raise of hands. Anyone attending the bar after?
8-ish? Say 10? Is this your updated slide after like 4 presentations? Okay, you were really like, does it matter if like sitting somewhere going the slides not good?
Oh no, I was writing a report. That's what that was about.
Okay.
And then I like walked to Mimiko Go Station. I remembered like the commute I used to have to make every day, and I was.
It was actually going to be like a reasonable assessment this week.
Yeah, I know it was great. I like didn't have to do like a lot of stuff. So
You didn't have to panic super hard.
Yeah, it was great. But the next couple months look like they're probably gonna suck. So.
Oh, so
you
they're
know.
like one week of fun, the next is like now
No.
you've had
It
your
was-
vacation, now suffer.
It was one low effort week so that you can do your performance review,
Oh.
and then it's gonna suck again. That was what the play was.
Great.
Yeah.
Oh, well.
What about you? Are you like you traveling soon? Is that Cleveland? Yeah, is that the
I'm
soon?
leaving on Sunday.
Right. That's why you can't make the next weekend.
Yeah, I'm going to Cleveland, and that's why I'm not calling in Elijah, because they're going to be up till like 2 a.m. And I got to get started and pack tomorrow for travel.
Yeah,
so.
totally. Wait, so like you're going there for work? Is it like an office there, or like? Oh, okay.
It's there's like my like they have they're on the Cleveland.
Change one slide. I just want to make sure it's updated.
Okay.
It's like
Good.
This is like 5 minutes to the Rock and Roll Hall of Fame in Cleveland. And my hotel's like across the street. So
Yeah, that's fun. There's like some stuff to do. You actually get to talk to people you work with. That's nice.
It's so weird.
Yeah.
Like it's like I don't see any of these people. Especially
Like
since
since you started, right? Like, oh my god.
It's like my other coworker joined. She does IR. What's it called? Yeah, like she went down to Boston to be the IR team there. Like the second week she joined, like that's what I expected, right? So I'm like, oh crap, I got this job. I got I can't start the job. I actually couldn't do that.
Yeah.
I panicked, like all the paper, express passport, everything, and then no. Not necessary to fly this.
Do you want to
Sure. Why not?
Alright.
Sure. I actually have one, but I forgot it. Thank you. Does it have like a laser as well?
It does have this.
Is it the center one?
It is the top button.
Okay. Okay. Yeah, that makes sense, right? Because what else would a top button be for?
Are you good?
Yeah.
I just want to start. I started this. Okay, hi. So this is our guest speaker, former student, current alumni. I guess is what you end up being. This is Elena. She's going to talk about cyber.
All right, cool. It's good to be back. Yeah, I guess it's a new semester for you guys. Wait, okay, I'm just curious, like, how many of you guys are fourth years? Third year? Second year? First year? Okay, cool. That's, like, not relevant to my talk at all. I was just curious, so cool. All right. Yeah, so this is actually my grad research on the topic of cyber warfare. So, little context, I only graduated, like, whenever the last semester was, so I guess technically 2 semesters ago, so that was back in August, and yeah, I slaved over this for 8 months, and figured, well, you know what, I shouldn't put that 8 months to waste. I should go tell people about it because it's an exciting topic, and I think especially you're probably all aware of the recent political tensions, so I don't think it's a topic definitely that everyone should, I don't know, be interested in or have some base information in. So despite these things happening recently, I think a lot of the sort of people have been saying like, oh, this is like cyber warfare is going to happen, or it's happening. And I really like the thing I came across when I was doing this research is that it's actually a lot more convoluted than whether it's just happening or not. There's a lot of discussion about what the word cyber warfare even means, whether we're already in like a cyber cold war or if cyber warfare is actually a possibility. So as we go through this presentation, you will sort of have a rundown of what all sides of the argument are, and you can decide for yourself whether we're having a cyber warfare right now. All right, so let's get started. Like all good talks, gotta start with a who am I slide. So my main gig is pen testing at Security Compass. That's the cool orange company, and they do a lot of pen testing, if you haven't heard of it. And before that, I did healthcare governance, got my bachelor's here, as I mentioned. I also really like cyber warfare because I tend to not really lean towards technical stuff. I really like more sort of the high level, like political, sociological, and economic dynamics. And luckily, cyber warfare is all of those things combined, so that made it really convenient for researching this topic. I'll start off by talking a little bit about the actual research methodology, because I think when we think about non-technical research, we think, oh, it's going to be easy. It's like you pick this topic, you do a little bit of research, you report on the research, and like, guess what, you have a great paper and it's, I don't know, going to change the world or like something. Of course, it's never actually as easy as they make it out to be in your capstone class. So, like all good presentations, I'll tell the story with a couple memes. So you kind of start off feeling a little bit like this. So I think, if I just Google cyber and war, like it should be fine. Like lots of stuff's going to come up, right? As you keep like going on, your brain feels a little more injected with information. You think, okay, there's a lot of things going on here, but maybe if I can separate what's going on into these buckets, so, political, economic, and sociocultural interactions, then I can start to look at the different trends between these data points and maybe make some conclusions. By the end of the 8 months, like, you feel like this. You've read so much information, and you come up with a weird thesis that goes something like, the fifth dimension of warfare is intangible because the spatial and temporal planes are simultaneously condensed and stretched. And that sounds like absolute, like, I don't know, like new age garbage, but it actually means both something and nothing at the same time. After you come up with this crazy thesis and you have to explain, what exactly you mean by that, you also realize this part that your prof did warn you about, but of course no one ever listens. Is when you have to like make the paper that looks like this, and it turns out when you've read hundreds and hundreds of sources and you didn't necessarily quote them or anything like that, it becomes kind of a huge task to go back and collect all these things and cite it. And then finally, you have your great thesis and think this is like some groundbreaking shit, right? Like this hot take is fire. But then you realize like some other guy on the other side of the planet like said it already in like almost the same words, and like you just kind of feel like, yeah, whatever. And then even after that, I mean, like, this research, like, if I can say it put me through something, okay? But, like, even afterwards, you look back at the emails you get. So if you're a broadcast student, like, you get most of your research through these free academia, like, email feeds. And they, you know, like, will take the past research you've looked up and say, like, oh, like, this is, like, research that you should look at because it's related. So I woke up to this email one morning. All I wanted to know is, like, you know, is cyber warfare going to result in, like, nuclear destruction? And then I got, like, 47,000 reminders of how that also could be a thing. So, you know, cool. Anyways, after going through this, you're probably wondering, okay, like, what possibly is this fifth dimension thing that you're talking about and could have caused you so much misery, and also, like, existential inquiry. So, the fifth dimension is not, despite, you know, also sounding kind of like hippie garbage, it's not. One of the first occurrences was this Air Force chief in 1995. He published a little thing about sort of when, you know, the internet was starting to get used frequently by the whole world. And he essentially said that, you know, this is becoming a new thing, and we have, oh, does this, like, laser thing work? Okay. It's ascending and transcending influence, which are, like, pretty big, you know, words that imply, I don't know, it's going to be a pretty big change. He says it has an effect mostly on our society and our military forces, and that he, like, officially sort of coins this as the fifth dimension of warfare, or also information operations, as you might hear some other people call it. And then finally he finishes off by saying dominating this sort of domain is going to be critical for military success later on in the future. If you look at more recent examples, this is again also true. It's like all you have to do is Google this term and you'll find, like, tons of sort of articles or research or whatever that use this term. What exactly does it mean, though? It's not an empty term. Oh, geez. Every time I make this slide deck, like, something goes wrong. Anyways. So you have the first four dimensions of warfare. These are, like, the sort of traditional dimensions of warfare. There's land, there's what's supposed to say air, but it says A. We have sea, and we have space. So these are pretty self-descriptive. If you think about land, like, that's like tanks or whatever. Air would be, like, airplanes. Sea would be, like, warships, and then space would be stuff like, you know, like satellite or GPS sort of assets in space. And also, why is this? Oh, okay, I see. Sorry, when you're dealing with a lot of slide decks, you end up with, like, 30 versions of the same one, and, like, there's, like, errors and, like, the little, like, transitions and stuff. Anyways, so we had all of these four, which we've referred to as kinetic space, and what they mean is that these spaces are tangible, so you can actually, like, see and feel and touch them. And this makes it a little bit easier to sort of imagine if you were to, say, create, like, a risk analysis about damage that is incoming. So if you think about a missile, for example, you can make generally a lot of conclusions that, okay, if the missile is coming faster, it's going to hit its target in a shorter amount of time, and that might also have, you know, conclusions about the amount of damage it causes as well. In cyberspace, this doesn't really happen. And that's what makes it so different from kinetic space, because all of these boxes, like, around the world just hold a bunch of electricity in zeros and ones, and somehow we have, like, an entire worldwide internet that, like, defines our identities, and has, you know, effects that will happen in other boxes across the world. But then their effects can be tangible later on, if they affect, let's say, you know, an identity that belongs to you, or information that you need to have, or information that needs to be correct. Exactly what about this makes it unique are the temporal and spatial planes I was talking about. So when I say that they stretch and condense at the same time, one of the easiest examples to sort of illustrate this is Stuxnet. So for those of you who aren't super familiar with Stuxnet, it was a malware that has been strongly speculated to have been created by the US to attack the Iranian centrifuges. This malware was created to essentially make these centrifuges spin at a faster speed than they're supposed to. So the centrifuges would wear out much faster than, like, the manufacturer said they would. And so eventually the Iranian sort of nuclear facility caretakers started to notice, hey, like, these centrifuges are piling up in like half the time that they're supposed to. Why is this happening? And so they did inspections. They realized eventually that there was malware on these centrifuges, and instead of making this plant like blow up or something, all it did was make the centrifuges move at a faster speed. So we have this aspect where this malware, when we think about it transferring from the, let's say, U.S. government to the centrifuges, they move at an insanely fast speed. Like, it probably only took milliseconds to cross all the routers and then actually reach the target centrifuges. But in terms of the damage, it took several months. I think this malware was running on these centrifuges for close to a year. So you see this sort of aspect where the actual transfer of the malware moves from hop to hop in milliseconds, but the damage is not explosive. We can't make the conclusion that it moving faster has caused more damage in less time. In fact, it's the opposite, where this damage is sort of stretching, and it caused a very slow amount of damage over time that was only noticeable after several months. So with this being said, there are a lot of different, if you're, let's say in like a military operation and you have to assess risk, this becomes very complicated because now you can't rely on the sort of physics of tangibility anymore. There's this aspect of you have to be able to make assessment based on things you can't see that might be happening already and really slowly, and that you may not have the attribution sort of assets to even tell if it's there or who sent it, who planted it there. So this being said, we have this fifth dimension, and we say, okay, cyber warfare happens in it. So knowing this, we have to ask, okay, but what does the word cyber warfare actually mean? It turns out in this, someone made this cloud, and it has a lot of words everywhere, and they all have to do with the debate over what cyber warfare is. It turns out, adding cyber to a word complicates a lot of things, because cyber is infiltrated into everything. Everything in our world is now, almost everything in our world is now digital. If you look at the term cyber warfare, it's not as straightforward as we would hope it would be. So Wikipedia was the first one that I looked at. It's pretty generic. It says cyber warfare is a broad term describing the use of technological force within cyberspace. It turns out that could be a lot of things, so it doesn't really help us. Google gave us a little bit better of a rundown. They sort of talked about the idea that it has to be an activity that a state or organization has sort of emitted, and also that there's this sort of aspect of intent to attack an information system for some sort of advantage in an operation. And also they provide this cute little map that sort of tells us about the history of the term cyber warfare. So this term sort of started being used when ARPANET was around. So if you've all taken networking, you already should know what ARPANET is. If you don't, essentially it was like the OG internet. It was created with a trusted basis between colleges and universities and educational institutions alongside with the military. And so the ARPANET actually undergoes the same pressure to the market as Nick was mentioning, where they actually have a lot of papers. If you look it up, I think Brand is the main institution that really holds a lot of these, and they talk about realizing this is going to result in a cyber war at some point in time because it's so insecure. But of course everybody was no, but we need to release this really good communication product, and so they did it anyways. So that occurred in the 1970s, which is sort of where this first bump comes up. The next bump comes up when the Morris worm came out, and this was technically not cyber warfare. It was just a virus that's spread really fast and far, but it was sort of the first exposure a lot of people had to a widespread mass scale virus. So a lot of people were oh my god, cyber warfare, and it was a little bit of a buzzword. Then after that, the world kind of calmed down, and then in the last decade, you can see over here, we started having more sort of nation-state sponsored activities that included cyber infrastructure. So then slowly, the term is starting to be used more commonly. Now, I mean, the word cyber warfare has a lot of contention. Other sort of doctrines have tried to narrow down this term into something more accurate. So in one international law doctrine, which I'll talk a bit about more later, they decided, okay, maybe like cyber warfare is too broad of a term, but they sort of coined a cyber attack as some sort of like operation happening in cyberspace. They said it can sort of have an offensive or defensive aspect to it, and that it's reasonably expected to cause injury, death to persons or thing, or damage to objects or destruction. Sorry, that's like badly worded. So the idea being that like it can't be a cyber attack unless there's some sort of like really damaging consequence at the end of it. But this leaves a lot of unanswered questions. So the first one is, how much damage, injury, death, or destruction do we actually need to call this an attack? Can it be like one person, or does it have to be like a lot of people or a lot of buildings? To whom and by whom? So can anybody just start a cyber war because they want to, or are there like restrictions on who participates in it? What are objects? Because, and do we mean like anything that's an object? Like, what does the word object actually mean in this context? Oh, whoops. And, I removed a point. Also, you'll see there's a point about sovereignty where we have to also define, okay, like, what sort of things belong in a nation state that can actually perform cyber warfare. So I'll talk a bit first about sort of how the world has tried to develop some governance around this topic, and then I'll go through each of these things and talk about how they've decided to try to define them and fit answer these questions. So the first one is cyber warfare governance. So there's this feeling, like we all know, when you become like an adult and you realize like other adults like have no idea what they're doing, and like everyone's just kind of like fumbling around looking for food and stuff. This is exactly what it feels like when you start researching cyber warfare governance, because you expect someone like Nadal would know like what cyber warfare is. It turns out that they don't really have a good understanding of like what it is or how to govern it. To give you a little bit of background on exactly what the sort of aim of cyber warfare governance is, we have this idea in international law called the object and purpose. And those words are pretty self-explanatory. Essentially, with international law, we want to provide a legal framework that has working definitions, because obviously you cannot govern anything if you don't have definitions to define like the entities in that framework, and therefore can't decide, what we should do about a certain entity within the framework. We also want to encourage a sense of legal obligation in order to inform state practice. So what this means is that typically in the world, there's no overarching government to govern cyber warfare, and that means there's no sort of body that can enforce, a breach of international laws. So if if a state breaks a law, there's no like international police to like come to their door and stop them. So what we try to do instead is sort of provide this mutual relationship with all of the states to sort of give them a moral obligation, which we call state practice. So the idea being that you want to encourage states, especially the more powerful states, because they have more influence on the world, to sort of buy into this moral framework. And then that way, if one of them breaks, a law in that framework, we can say, hey, you're like a bad state. On the contrary, if a good state, a more powerful state does something that we would consider good, then all the other states will look up to that state and go, wow, like that's such a great state, we should follow suit. Both of these sort of concepts are used to reduce conflict and mutual escalation. So conflict is pretty self-explanatory, essentially, like a war or something like that. And mutual escalation is the concept where if one nation state starts some sort of conflict and then another nation state responds in kind, then we can sort of assume that the first nation state is also going to respond in kind again, or perhaps have a slightly more damaging action, and then that cycle repeats where the other nation state, performs a more damaging action, and then eventually you'll escalate into a full-blown war. And as you saw before, perhaps that'll become like a all-out nuclear sort of like conflict. So we don't want that to happen. Finally, all of this is used as an ultimate goal to maintain international peace, because why would we have any of this for any other reason than to,
keep nation states in check and keep, wars from breaking out all of the time. So some of the past attempts to do this, you've probably heard of them, at least probably the United Nations Charter and the Geneva Conventions. A little bit lesser known one is the Hague Conventions, and all of these were created within the last 2 centuries after conflicts and wars. And essentially, these are giant law sort of rule books that say, they dictate what happens before, during, and after war. And so the contents of these books look like things like, how many things count as a war. So like I was mentioning before, they have this concept of how much damage you can cause before it's just like a domestic problem versus like an international conflict. They also have sort of concepts about what kind of participants are in cyber warfare, and again the objects too, who you can do it to. And they also just get some really granular details, like exactly what color of red the Red Cross has to wear, or what kind of uniforms count as a war uniform, or what kind of religious people you can send as support to your war prisoners. There's a lot of nuances like that. So these documents it's really interesting to sort of see what the world thought was morally correct back then, and sort of the obligations they thought as basic human decency to sort of send to people involved in a war. The thing about cyber war, though, as we all know, digital law is never developed in anything. You probably hear about more of this in privacy, but essentially the consensus is there's been no international community event like the Geneva Conventions to create some sort of doctrine that everybody has both agreed on as well as signed into formally. So without that, it leaves a lot of questions about the possibilities of what people can do in cyber warfare in the future, and how we're going to claim that they broke any sort of law. So the first attempt at this is called the Talon Manual 1.0. It was created in response to the Bronze Talon soldier attack. So this attack happened in Estonia. It was an attempt by their government to move this war monument, and the Russians were really unhappy about that, so they decided to just hack them basically. And the hack was big enough to affect a lot of their sort of core state functions, so stuff like financial sector, social sector, education, all that kind of stuff. So it was sort of one of the first big hack events that people saw. So people in the international community said, well, why don't we try to reimagine the international law we already have, like the ones in the Geneva and Hague Conventions and the United Nations Charter, and try to see if we can transfer this into the cyber domain. So one of NATO's sort of organs decided to do this, along with a couple other big name international governmental organizations. And what they came out with was this book, which is inspired heavily by warfare manuals and doctrines. So this might be stuff that they give out and say the Marines or something, they actually give it out to the soldiers, which usually contain stuff about how to conduct operations, but also about the philosophy and ethics and morality of warfare. They also included conventions, protocols, treaties, and statutes that already exist. So the Hague and Geneva Conventions that I already mentioned, or there's tons of other smaller ones that sort of exist out there. And then finally, significant international court cases. So if something happens, if a war crime happens on a mass scale, then they try to take it to international court and sort of decide if which party was wrong or right. In all of this discussion, there is a debate in global governance where they say, well, if there is no international body to actually police any of these actions, then all of this is useless. The international court is useless. All these laws are useless. For the purposes of this discussion, we're just going to pretend that the law is useful in some way, shape, or form, because otherwise the rest of this research, all of the work that these people have done, is essentially useless. So while this manual existed, it only really touched mostly on what happens during war, and it omitted a lot of what happens before and after war. So they decided, well, okay, this manual I made is like a bit outdated, so 5 years later they decided to create the next update of this, and it looks like this. And if I have any way to describe this book, it's thick, because like I read like all 600 pages of it, and like, oh my god, there's so much information in here. Like, it includes like pretty much all of the things I mentioned, as well as like reimaginations of all those really granular things, like, you know, what kind of stuff can you wear to war. But then it even ventures into stuff like, you know, like international human rights, and you know, what's some of the like really granular things, like what is the cyber law in like airspace, sea, and land. And you think that kind of stuff is going to be really interesting, but it's actually really boring. You know, it's like space law sounds great, right? Like cyber war in outer space, and they're basically just like, oh yeah, well, like, you know, like internet assets like exist on space stations, and like it's like the same stuff that happens on like every Earth attack. And I was like, oh, this is like, you know, kind of lame. So, or they talk about like exactly how high, like how many miles in like the air counts as like airspace, and then it becomes like outer space. And I was like, I'm never gonna remember that, but sure. It's important to somebody, I guess, though, so, you know, no harm, no foul. So this manual exists, and if you like look up cyber warfare, this is sort of like the main thing that comes up. If you even look into like academic literature, this is like the book that like a lot of academic papers will analyze and sort of talk about like the problems inside of it. So one of the main issues with this book, which has been formally noted in the introduction of the book, is that it's unofficial doctrine. The reason being because it reflects lex lata, this concept essentially meaning the law as it exists, versus lex ferenda, which is the Latin translation of what the law should be. So all this book really does, I shouldn't say all this book really does, what this book does is essentially talk about, okay, cyber warfare exists right now in these circumstances, and there's these events that have happened where we can't really decide if it's cyber warfare or not, but they don't talk about what the law should be, or like how we should enforce it. And so you're going to see some of the biggest sections where there's like the contention, because we haven't actually talked in this book about what we should do. The first one is sovereignty. So we have this idea like of a nation state being sovereign, and it's kind of kinetic and geolocational, which is problematic because cyberspace, as we saw, doesn't really have like physics, the same physics as tangible objects. We also have the idea of the use of force. This is essentially an attempt to grade how bad damage is. So going back to that question of like what is war, what counts as a cyber attack, you're going to see in this manual that it's literally undefined. Likewise, we have this concept of military objects, and it's a very dichotomic sort of concept, which doesn't sound so bad at face value, but when you start talking about cyber assets, the problem is they're so multifaceted that we can no longer classify them as one or the other. And then finally, we look at international actors. So in general, in international law, and I mean, back in the day, this made sense. In kinetic space, we say, you know, international conflict has only to do with international nation states or other organizations, because if we're talking about kinetic space, it makes sense. Like, only really nation states have the power to start like a mass like world war. But this no longer becomes true in cyberspace, because it's really easy to release a cyber weapon that can do a lot of damage, and like one person can code it. So before I'll talk more about these issues in the Talon manual, I'll show you what exactly it looks like. So I picked, you know, I honored the 12-year-old in myself and picked this wonderful rule, because who doesn't want to learn about what cyber booby traps can do? It's actually a really boring rule too, so disappointing. But essentially you have the, where's the laser? Okay. Oh, does it disappear? Okay. You have the rule. This is not, okay, I'm just going to not use the laser. My fingers in front of the I don't know how I graduated this program, man. So you have like the definition of the rule. How they came up with the definition is a group of scholars, it was about a couple tens of international law scholars and a couple IT experts. they essentially debated about how a rule should be formulated. And so you can see the source of this debate. So they talk about a majority and minority consensus, essentially saying they'll have two opposing viewpoints, and depending on which they vote on, one of them is considered the majority because more people voted for it, and one's a minority because less people voted for it. So you can see them talk about it. Let's see this. Where does it say it? Okay, this one doesn't have majority or minority, but you can see like it says like the experts agreed about like something. So they'll talk about what they agreed on. They'll also talk about what they didn't agree on, and sort of like the nuances of like why the different sides didn't agree on it. In some of them, they also talk about just generally like the difficulty of understanding the concept in the context of cyberspace and how that caused issues for the like legal team to sort of dissect, how this would actually play out in the real world. And then finally, they sort of give just like examples of scenarios where this rule could be violated in the real world. So that being said, let's jump into some of the things that are contained in the Talon Manual. The first concept I'll go over is sovereignty. So it's a pretty old concept. Essentially, this concept means, if you have a state and there's stuff that like sits on the land in that state, then it belongs to the king or queen of that state, which makes, intangible reality that makes a lot of sense. It doesn't make quite as much sense when you start adding cyberspace as like a layer of reality on top. So the very first rule of the Talon Manual is this principle of general sovereignty. And so the definition makes sense. It just says like state sovereignty applies in cyberspace. So it seems like we're off to a good start. When you get to the second comment though, it talks about the supreme authority of the prince or king. So we're already talking about how dated it is, because like how many places actually have a monarchy? Only 43 out of 195 countries have a monarchy today, and only 26 of them are actually unique monarchies because some of them own like different states. So it's already pointing to sort of like an outdated concept trying to, describe cyberspace. They sort of try to just cover that up by saying applied to modern international law, the state. But I think, the core of that law has existed for hundreds of years. So it's going to come from, an old, archaic, tangible sort of conception of like what this rule is. They continue to say, for the purposes of this manual, there's sort of different layers that are wrapped into this. So there's physical, logical, and social layers of cyberspace that make sense, and they're encompassed in the principle of sovereignty. So at a base, at face value, this makes sense. As we keep going through some of the other sections, though, you're going to see how this really doesn't actually manifest the same way as they've described it to so easily do. One of the other main sections that they talk about in the context of what happens during war is this notion of armed conflicts and the use of force. So essentially, these two terms sort of define like what is a war. I'll outline like a sort of high-level diagram just to make it more clear as we go through the text. But essentially, we have this concept of armed attack, and when you do an armed attack, this grants the other party that you're attacking the right to self-defense, so they are allowed to do a similar thing back to you because you hurt them. And then finally, this cycle repeats, so as you keep trading like armed attacks with each other, then this creates like an overall armed conflict, which then happens over time. But so we have to ask ourselves, okay, this armed conflict happens over time, but what exactly is it? There's a rule specifically in the Talon Manual that talks about this. So we have this idea that there's hostilities, which makes sense, and it's between two or more states. But then one of the next comments talks about how there's a huge controversy as to what the threshold of requisite violence is. So that essentially means like we don't know how much hostility that like actually implies. And then they also refer to this in one of the rules about self-defense against armed attack. We sort of get into this idea where some cyber operations could be sufficiently grave enough to sort of like count as enough damage, whatever that might be. And they talk about the fact that it doesn't have to be kinetic damage that's done. in order to cause serious suffering or death, which like we would assume would sort of fall under this idea of armed conflict. Some sort of other, so if we're going back to the idea of Stuxnet, where this damage happened over time, in essence, it didn't actually destroy like a huge amount of buildings, let's say, and it didn't kill anyone. That being said, you could argue that without these assets, it causes serious suffering or death to some people. And this is sort of equivocal to, let's say, chemical, radiological, or biological attacks. So there's this sort of idea that, like, even though cyber attacks cannot be or won't necessarily cause instant, damage to objects or people, a long-term sustained damage to a lot of people that might cause a lot of pain might still count. How many lethal cyber attacks do we actually have to date, though? We don't know. There's only one cyber attack that potentially killed people, and because this happened in the East, we don't have a lot of translated public sources on it. So we don't even know, what this lethality count is. So this causes a problem when we talk about armed conflict, because there's a sort of idea that it has to cause enough damage, but we don't know how much enough damage is. So we could maybe look, okay, if we can't say that like an armed conflict is happening, what about the use of force? And the use of force sort of is like the underlayer of armed conflicts. It's the thing where you like cause enough of a problem to some other nation state, but it's not enough to, let's say, kill people or like destroy buildings. So we take a look at this and we sort of run into the same problems. The definition of it is pretty straightforward. So essentially we say that a use of force will be any sort of threat to some territorial integrity or political independence of a state. So obviously if you like destroy buildings and sort of kill people, that counts, that like falls under that umbrella. But it can also be something like disinformation campaigns, or I don't know, like messing up their economy or manipulating their media, or at least that's in terms of the words that they're using. That's something that would count as like political independence. As we keep going though, we come across again this idea that, okay, we can like determine how much of this damage occurs if we can sort of break it down into scale and effects, and that these scales and effects should be comparable to rising to the level of a use of force. Now the issue is though, the next comment talks about, or the second comment talks about how there is no definition of the use of force. So essentially we have all these rules that are, relying on the fact that we need to breach the level of use of force, and then we just don't have a definition of what that is. Further on in the comment, they also explicitly say that economic coercion, psychological operations, terrorism, and espionage don't count as use of force. This is kind of problematic because if we go up back to the first definition, those are sort of like the only activities that would actually fall under that umbrella. So really, we just don't even we have no idea if things happening in cyberspace can actually fall into any of these buckets. And therefore, we can never definitively say, at least in the context of international law, whether a cyber war is actually happening. To sum that up in a more high-level diagram, because that can be kind of confusing, essentially, the more damage you do will sort of like result in an armed attack up there. Again, this is a component of an armed conflict, and in easier words, a war, and it sort of implies like things have been destroyed or people died. And then under that threshold, we say, okay, like there's some other damage apparently that isn't quite a war but still affects things, and it's pretty bad, but it's not as bad as an armed attack. But at the same time, it's not any of the things that we would typically, assume to cause those kinds of problems, like the items that I mentioned already. So that being said, we're pretty much, off to a really bad start in terms of like deciding whether we have a cyber war or not. It gets worse when we talk about military objects, and this is probably the weirdest part of the research I did, because you get like these like borderline existential papers about like what the word object means, because these laws were created, a lot of them were created in the modern era, and back in Europe, and they were all created in different languages. So you have these papers like dissecting, is the word object like thing, or like object like objective? And then they talk about like the breakdown of the root of those words in different languages. And it's a really like insanely granular sort of dissection of like this word that, we think just means like, okay, that must be like a thing you attack, but it's apparently a lot more nuanced than that. So beyond nuances of words, we also have to ask, okay, which of these, so we have this concept that like an object is, for simplicity, we'll just say it's a thing and it's in a war. So things like buildings can count as that. We have this idea that like people also become objects of war if they participate in it. So like if you're a soldier, you're a military objective. And when one of the rules, they break down sort of how these things are decided. So this rule, you can see, it's called civilian objects and military objectives. And we have this sort of dichotomy that each object can only be one or the other. So in the first part of the definition, we see civilian objects are just any objects that aren't military objectives. So reinforcing that dichotomy. If you want to illustrate it, it's really quite simple. The two things are mutually exclusive and you can't be both. How exactly we come to this conclusion is based on what this object or objective is for. So they have these factors that they use to determine what it is, their nature, location, purpose, or use. They're pretty self-explanatory words. Essentially, what was this object created for, and what does it do? So you can think of something like, let's say, I don't know, a tank is pretty obviously a military objective. It's made like for the purpose of like shooting stuff and like protecting the people inside of it, and going to war spaces to do war things. In addition to this, we also have this idea that it needs to offer a military advantage. So even if something like a gun, for example, is created, you could say, okay, that causes damage, so therefore its purpose is to cause damage. But in order for it to be sort of a military objective, there has to be this idea that assuming ownership of this gun would actually offer some advantage to the military operation that's happening. And then finally, at the end of this, we sort of just make a blanket statement that says cyber infrastructure can count as a military objective. So, I mean, in tangible space, this makes sense. Like I talked about the tank example, there's things that are very obviously not a military objective, like, I don't know, like really like a spoon or something, right? Like that's definitely not made exclusively for like use in the military. The problem is when you have computers, we don't have a way of defining whether or not they are exclusively used for war. So someone can sit down at a computer and check their emails and like email their family or whatever, and then someone can also sit down at a computer, the same computer, and send off malware that will go destroy, Iranian centrifuges on the other side of the world. And because attribution is so hard, this also like further amplifies the problem, because even if we were to look at a computer that has exclusively done, let's say, military actions, you can't necessarily say who did it, or that it was caused by someone trying to gain a military advantage. So essentially what this means is that computers and other cyber assets exist in both of these domains, and it crosses this boundary. It exists simultaneously. It's no longer mutually exclusive. And so this whole concept really just falls apart. We can't say that this is a law that makes sense, or a concept, a methodology that makes any sense anymore in cyberspace. So now we have an issue of actually, defining what we can perform war on or to. The comments in this rule also sort of address this. So they talk here about questioning how the internet exists as a military objective. So one of the sort of things they talk about is that once an object is used for military actions, it becomes a military object and it can't be like converted back into a civilian object anymore. So now we have this issue though, because obviously militaries use portions of the internet for military advantages. So we have to ask this question, well, does that mean that the portions of the internet are like solely for military purposes, or is the entire internet, because it's connected, you know, do we conceptualize it as one object that is a giant military objective? And then how do we sort of compensate for the fact that a lot of normal civilians also use the internet, because obviously they're not military objectives. They also further sort of say, you know, it's unlikely that we would have a point in time where the entire internet is used as a subject for military operations, which I think reflects exactly how many of these people are not IT experts and are international law experts. Because we've seen things like Mirai, for example, where, you know, 2 kids trying to sell their DDoS service ended up taking down like entire, like, you know, portions of nation states with their botnet. So I don't really think it's that infeasible. I feel like if a larger, more directed group were sort of put their heads together to do this, it's totally possible. So this being said, you know, we have this contention. We don't know what a war is. We don't know exactly what we can do a war to, whatever you know, doing a war would mean. And finally, we sort of have to ask who can actually participate in this war. So in international law, we have this idea of international conflict, as I mentioned before. It's some sort of conflict that happens between nation states or other sort of like internationally sovereign bodies. And this happens typically between nation states or possibly between organizations that operate at the international level. And for every single rule, like they will state this, that if this is not the condition that's happening, so let's say if it's not a nation state versus not a nation state, or if it's a nation state versus not a nation state, then it becomes an issue of domestic law and it becomes a non-international problem. As we all know, though, non-state actors can cause a lot of damage. So let's look again at how sort of the discussion in the Talon Manual around this concept. So they say, you know, in this rule against about self-defense against armed attack, they talk about the idea that, again, there's contention over whether non-state actors can actually participate in an armed attack. They specifically state the example of 9/11 because that was an act of terrorism. However, the international community widely agreed that this was an armed attack. So now you've already, you know, breached essentially the parameters that you set out. They also say that states can practice like a right of self-defense if a non-state actor does something to them that is damaging enough to be called an armed attack. Which, I mean, is great from a perspective of, you know, giving them a right for defending themselves. But again, if we're going to call any actions by a non-state actor to be domestic law, then it doesn't make sense that they're crossing over to a concept that exists in international law. So again, we have this crossing over of sort of methodology to assess these situations. And then finally, they again conclude that there's significant uncertainty about exactly how much organization a group must have in order to make an armed attack. So what they mean here is, you know, can a group of, let's say, just sort of randomly ad hoc organized hackers, such as, say, Anonymous, actually count as a non-state actor that can sort of create an armed attack, or does it have to be something more organized like a cyber mercenary group or some sort of like state-affiliated APT or something like that? So again, all of these questions we just simply don't have an answer to. So you can look back on all of this and ask, you know, what is the nature of cyber warfare? And the answer is we just have no idea. Every single, you know, sort of main concept in the Talon Manual essentially comes to the conclusion of we just don't know. So if from a theoretical perspective we can't make any assumptions, we can perhaps try to apply the methodologies that they've applied to real-world scenarios. So that's exactly what I've done in the next couple of slides. So these are the significant sort of cyber players that exist today. So most of the conflicts that you'll see internationally have to do with these nation states. They've all invested like an incredible amount of sort of like money and manpower towards having a cyber army, and not even just recently, but through the past. And it manifests in a lot of different ways. It's not just making malware. It's stuff like disinformation campaigns, attempts to manipulate like the media and psychology and economies and stuff like that. And you'll see sort of how some of these have interacted in some of the most like paradigmatic cases. So my 3 case studies, the first one, the Ukrainian power grid attack, I took out because this slide deck was way too long. But as we go through the other 2 cases, you could sort of think about how this methodology can sort of be applied to a power grid getting hacked by a nation state. My second case study was the DNC hack, which I'm sure we're all familiar with. So we'll be going through sort of some of the events that happened and the issues of defining, whether or not this was cyber warfare. And finally, a conflict between Hamas and Israel. This happened right at the end of me doing my research, and it was a good one to analyze because this one actually was the armed conflict I was talking about, where there was destruction to a building. So it's really interesting to look at this one and sort of talk about whether or not it was cyber warfare, because there was destruction to an object. So my first case study, the DNC hack. So essentially, we start off with the DNC. We have the Bears. These are the Russian state-sponsored APTs, if you're not familiar. They sent a spear phishing attack, and specifically, they sent these malware tools to the DNC. These initial attacks were super low tech. All it was like, tricking an IT admin into like putting a password somewhere, and this malware that they used essentially gave them like persistence in the network, and they used that to do information gathering, and they stayed there for a couple years. Now, allegedly, both of these groups, they were operating in tandem, but they didn't actually know anything about each other. So different results happened out of those 2 things. The first one resulted in the WikiLeaks leak, which had like 20,000 emails disclosed, as well as 8,000 attachments. And then the second one resulted in another, I think it was like 50,000 or so emails being leaked later. And so the interesting thing about this hack is that it was considered an election hack, but at no point did they actually touch, let's say, like the tally of the elections or the election machines. All they did was break into this network, sit there for a while, continuously collect information, and then they used this information to manipulate information surrounding the DNC election, or the election between DNC and the Republicans. So one of the first things that happened was the WikiLeaks document leaks, which I already talked about. They also found, so FireEye and Mandiant and like all the other big sort of consulting companies did an analysis on this hack, and they found that there were Russian bot targeted ads for certain areas in the US, like specific states. And essentially, they were trying to just sort of peddle like sort of right-leaning in Facebook ads to people. And it's believed that this widely swayed a lot of the areas that were sort of like in the middle and couldn't decide. We also had the Don't Shoot Us campaign. So this was part of the Black Lives Movement. And Russia didn't, or the APTs didn't actually inject like false information into this, into the discourse surrounding this movement. All they did was significantly amplify the traffic of this movement. And because it was such a divisive topic, this was sort of like a key factor in also swaying the voters, because if they were in the middle, then they would start to sort of like feel very strongly about a viewpoint related to this topic, and that would help them sway to the right as well. And then finally, they also found that these hackers had planned a post-election hashtag. So they were aware that, again, because they're not directly manipulating the machines, that this is probably going to help sway, but you can't actually determine like the exact outcome. So just as like a last final blow, they created a hashtag called DemocracyRip just in case Hillary won, and this would have been the one that they released right after the election. So a lot of attribution happened after this because all of these hacks were happening while the elections were happening, and a lot of investigations were going on. U.S. attributed Russia formally, so they publicly said in their releases that we believe this is Russia. So there were the third-party investigations, as I mentioned, by all those firms. The NSA at some point released a declassified report. This one was really interesting too because there were negotiations going on with Syria at the same time. So some of the scholars were in academia were sort of wondering, why was this release so low key? Like, why did people not hear about it? Why was it not blowing up in the media? And the reason was because Obama, so in international law, you sort of have to agree that you're in an international conflict. You have to do this action of attribution, and both sides have to do it. And so Obama didn't want to rock the boat by pointing the finger and saying that this happened while these negotiations were going on. And so this is why this report was released so quietly. And then finally, Obama did eventually sanction a bunch of Russian diplomats, to which Putin was not very happy about. The specific groups that were attributed in Russia to these actions were the Internet Research Agency. So you might have heard of it. That's like the troll factories where they literally hire people for the sole purpose of pissing other people off on the internet, and sort of trying to inject political opinions into social media. And also the main intelligence directorate, also known as the GRU, which is essentially the Russian FBI. Putin denied this attribution. He suggested that all of these actions were just patriotic hackers, that there was no nation-state affiliation to it, and also that he cited the sanction response as bad relations. So he was, he tried to frame it as you sort of made these sanctions against us without any purpose or reason. Now, the interesting thing about this is that all of these actions were sort of sublethal. They were not, killing anyone, destroying buildings. But the whole world kind of seems to agree that this was cyber warfare, and quite a significant instance of it. As we go through this methodology, though, you can see that it doesn't really fit the bill for what we would consider an armed attack, or maybe even a use of force is questionable. So if we look at all of the things I outlined before, we can look at whether it's an armed attack. So this is obviously really unlikely because there were no kinetic consequences, nothing blew up, nothing happened to the people. You could maybe make the argument that election tampering is a form of violence to the people, just because political integrity is a political right. It's a right of a people in a nation state. In terms of the use of force, we could say yes and no. So we have that clause again where it's territorial integrity or political independence. So if you talk about, okay, you ruined how an election was supposed to happen, then you would think something like political independence sort of falls under that category. But again, this definition explicitly said that psychological and media manipulation doesn't count. So if we're going by those restrictions, then technically nothing damaging actually happened. If we ask who actually participated in this conflict, the U.S. has explicitly attributed Russia, so we can agree that the U.S. has sort of implicated themselves into participating in this conflict. However, Russia does not attribute themselves as a player in the conflict, and without their government formally saying yes, we participated in this conflict, we can't actually call it an international conflict formally. And then finally, if we ask about military objects, this maybe counts, because you have to ask, okay, are the DNC targets civilian or military? If we think about the actual attacks, the malware attacks, and the targets of those attacks, you can make both arguments, because the spear phishing targets are just people, right? At the same time, you could argue that because they perform some sort of action that is inherent to state function, that they are a military objective, because taking them over or compromising them would, give them a military advantage. So it really comes down to now this question of like, are people like a military thing, and also are the targeted civilians also an operational object? Most of these attacks worked on the idea of sort of manipulating how people think and how they sort of perceived like the election campaigns, and ultimately it changed like who they voted for. So no, that really makes you question, like, is every single person in a nation state, every civilian now an operational object? We don't really know. My conclusions on this are that, well, just like the talent manual, I say they're not definitive. And I think that this conflict really strikes sort of like a middle ground between a cyber operation and a cyber war. Because, again, there is no, kinetic damage that happened immediately or effectively. But at the same time, it has a very real kinetic effect that, like, the next 4 years are going to be guided by a president that maybe potentially probably would have won. So that's, it's a very interesting thing where, like, again, going back to that, like, fifth dimensional concept, it doesn't necessarily have, like, a lot of damage can be caused not necessarily with a kinetic explosion or someone dying. It can be caused slowly over time. The second case study is really interesting because it's nature is really sort of opposed to how the DNC hack happened. So we start off with Hamas. For those of you who don't know, that they are a sort of like religiously oriented militia group, and they took over parts of the Gaza Strip. And at some point, they allegedly performed some sort of cyber attack. We don't know when it happened or like any information about like the malware or how long they're on the network, what they did with it. But what we do know is that the Israel Defense Forces, also known as the IDF, sort of responded at some point. So I'll give you a second to read the tweet. So it's a pretty salty tweet. And essentially, like, this resulted or coincided with an airstrike happening on a Hamas headquarters in May 2019. Some of the comments of attribution from both of the sides, so Hamas didn't really have a lot of comments or any comments on it, at least not from research that's been translated in the West. But the IDF, on a translated website, they sort of talked about this. They said that, like, they noticed that this cyber operation was happening and that it was, targeted at their headquarters. And that after handling the cyber dimension, they also handled the physical dimension. So they've obviously crossed this line from just like, information warfare into some sort of like kinetic strike. Now the interesting thing is that unlike the DNC hack, which everyone said was cyber warfare, most of the research or discourse on this conflict doesn't call it cyber warfare. We have maybe like one top headline here that says, oh, it might mean something for cyber war, but everybody else just calls it like a cyber attack or says it has some sort of implications on sort of cyber happenings, right? And so it's a really interesting distinction because you would think that the fact that a building blew up, potentially people died inside of it, would sort of preclude it into being an armed conflict, but it doesn't. So going back to that methodology again, let's look at exactly some of the nuances with this case study. So in terms of armed attack, you have to really ask the question of, are you going to consider this conflict as in two individual operations that happened or as one sort of like whole interaction? Because if you're talking about just one interaction, then like loss of life and potentially and also property happened. But that being said, we don't know what the cyber sort of attack was in the first place. So this can be seen as an inappropriate response to this cyber attack if maybe this like only counted as information warfare. And so then if you were to split it up, you could say this technically isn't an act of cyber warfare, it's just an act of warfare in response to a cyber operation. So now we have to sort of like decide what that distinction is. In terms of use of force, we can certainly, conclude that this was a use of force, but again, we fall into that same problem. So if something is an armed attack because, stuff got damaged, then that implies it's a use of force because it's just a subset of that. But again, we don't know if like the cyber initiation was like really actually at the same level of damage, and therefore we can't decide if we should split those two events up or count them as one. We also have to, this gets more complicated when we're talking about who participated in it, because Hamas is not technically a nation state. This being said, though, because they're occupying another sovereign area, they sort of perform the actions of a government to some extent. In politics, we call this a sub-state actor, because they aren't like a sovereign state, but they sometimes do the actions of a state. So now we have to ask the question of like, does this count or does it not count as cyber warfare because they're not technically a nation state? And we sort of have to, determine where this threshold of like organization really falls. And then finally, when we're talking about what sort of was included in the conflict, it's really unclear as to what the targets of that cyber attack were, because again, we don't have like public translated information about it. And it's also unclear if the target was an official military headquarters or if it was some sort of like other headquarters. And again, this also has to do if we're talking about a sub-state actor, because they're not technically like an official nation state military. So really, like all of these things, we just also, again, don't know. So my sort of conclusion on this is that the cyber component of it is not really like cyber warfare, because again, nothing blew up or died. And the kinetic response is most likely unlawful, because they would have had to prove that they are responding as self-defense in kind to something happening on the same level of damage. And so if no one died because of this cyber attack, then it certainly can't be said that the kinetic response was appropriate. So this all being said, that was like, sort of a long rundown of these different cases. So I've summarized like exactly what we said in this table about whether or not any of these things actually sort of meet the nuances of the cases. And as you can see, none of these boxes like strictly have a check mark by itself. So really the main conclusion about all of this is this book that is like supposedly supposed to define how we rule cyber warfare today, it doesn't, when we use a framework based on the how these things are defined, we don't actually get a clear answer about whether cyber warfare is happening or not, or has happened in any of these events. So I'll talk lastly about what exactly we would need to do in the context of this framework to actually hopefully help make this make sense. The first one is to clarify what counts as war. So again, if you have some sort of like metric or risk framework relying on a threshold that says this is or isn't war, then we need to sort of define those definitions to say how much damage will be counted as an act of war. We also have to sort of clarify the inclusion of non-state and sub-state actors, because again, it's been made very, very clear that non-state actors can do a lot of damage and at an international level, and we can't just ignore the damage that these events cause just because they aren't a sovereign state. And then finally, we also need to resolve the military-civilian dichotomy, because again, basically any asset that is a computer fits into both categories. So we can no longer say that a computer or cyber infrastructure can or can't be a target, because it fits into both parts of the dichotomy. There's also, again, in meta-conclusion, going back to that expansion of temporal and spatial planes, I think a theme in general of all of this research is that we use a lot of dichotomies to define things because that is easy in the tangible world, and it's not something we can do anymore because cyberspace is a lot more nuanced than that. There's also some weird conclusion about extra dimensions here. All I'm going to say is, the internet or ARPANET was, created about 50 years ago. Right now, they're saying quantum computing, if it does happen, is going to probably happen or probably be feasible to use in the next 50 to 100 years. So who knows what the quantum dimension of cyber warfare will be. That'll be an interesting thing that I hope I love to see. And finally, international law can no longer just be based on the idea of tangibility, because again, going back to the dichotomies, it just does not work in cyberspace. If you're talking about more practical conclusions though, what we can do on an international level is sort of again, work to solve those conceptual loopholes that I've framed, make some sort of event that is like the Geneva Conventions, but for cyber warfare. And there's definitely been efforts to do this, but none of them have been official as the Geneva Conventions. And finally, make the framework actually official, because this is a non-binding law. If no one actually agrees that they need to follow this, then these frameworks don't actually mean anything. So yeah, that is the end of my overview of cyber warfare. So now is your chance to roast me.
So I guess you'll have a new use case coming up for the Iran.
Oh yeah. I've been looking into CFP submissions and stuff, and I was just this is gonna be some updating I need to do. Yeah.
Do you think that governments should have the responsibility to prevent non-state actors in their own countries from committing cyber operations?
That's a good question. So there's this concept called jurisdiction, which is basically that, both on a state and non-state level, where they say you have a sovereign state, therefore you need to be responsible for the things that emanate out of your state. So I think, yeah, definitely the basis of that is there. And I mean, with domestic law, the idea is supposed to be you just have a general concept with PIPEDA where you're not supposed to I don't know, damage other people's data. Is that realistic though? I think it's a different question. In a perfect world, it should be responsibility of the nation state. But I think as cyberspace is just so all-reaching that we have to treat international law to fit the nature of cyberspace rather than trying to force how we govern it into these buckets again. That's my take on it. You had a question there?
Yeah, given the sensitivity of the subject and I guess the timing of it, it seems how difficult was it for you to find any research based on the DMC attack?
Really easy actually, but I think the biggest challenge with that was just the volume of information, because I don't know if you've seen, any of you have seen, I think one of the newspapers published a timeline on the DNC hack, and this thing goes on forever. It's a 2-year-long conflict, and it seems every couple of days there was something happening, and it's not even just they're all technical events. There are events that are anything between the actual phishing attacks happening or the sort of official statements between US and Russia, or there'll be just stuff that Obama said to his team or the US people, or things they could gather about Russia's interactions with it. And also, again, the information manipulation and media manipulation campaigns. So it was really difficult to go through that and sort of decide, how do you pare all this information down into just the things relevant to what I'm talking about, and sort of but at the same time give enough context so that people actually know what's happening.
So in the kinetic war, a big part of it would be hiding weapons or hiding whatever, and that's much easier to do in digital war. Do you
That's a really interesting question. I can't say I know the definitive answer to that. But I was reading more recently just about sort of some of like the nation states' different postures. And so like some of them will have like certain strengths in areas and some of them won't. If you think about like attribution, then it's like a lot of consulting companies who like focus on this sort of like international concept and stuff. They have an idea about like, let's say, which APTs like use which tools and like the structures of those tools and sort of like reading the actual code and seeing like things that are familiar between different code bases. And that's actually like a lot of how they determine sort of like who was behind an attack. So I don't know, I think like there's definitely enough eyes in the world to sort of have a good idea of that. But it's hard for me to say because in the West, obviously, we're going to see a lot more Western research on it. Are there huge consulting companies like that in like, let's say, Israel or like China? I have no idea. China probably actually, because it's just so big. Another interesting thing I was reading is just like the fact that Russia invested in their cyber infrastructure so much earlier than like a lot of other nation states. So their teams are not nearly as big. But I think a lot of their research, and I mean, I might be misspeaking. It's been a long time since I've like looked into that specific thing. But it seems like they were a lot more focused on like actually exploit development and like campaigns and stuff like that, rather than having like private companies that are sort of watching this across the world. So yeah, there's a lot of interesting interactions, and it's even more interesting because like there's private industry that's invested in this too. So we have a lot more freedom typically overseeing that kind of information. And yeah, honestly, I don't know from the perspective of other countries.
What's your take on hackback and proposed like legislation where it would lead to cyber warfare against like nation states, especially with attribution being so difficult, right? Given obfuscation tactics.
Yeah, that's an interesting question. I think like it's difficult because that's obviously going to lead to mutual escalation, and the fact that you can't see like as easily what actors are doing with attribution, I think it can lead to sort of like releasing cyber attacks that maybe won't have as specific of a target if you make the assumption that like I don't know, like someone has done something. So the idea being that you can like pull some sort of like nation states or parties that are not involved because like your attribution wasn't accurate enough, and then they become parties to the conflict. And the Talon manual actually like tries to address this too, again with jurisdictions. So they have this idea of both pulling in other parties and also the idea of using like different nation states as like proxies, like just like literally using their infrastructure as like a technical proxy so that it appears like the attack came from them. So I think, yeah, overall I would say it's not a good idea, even though obviously like from a defense perspective, like that would be the ideal thing to do. But with the way the political tensions are in the world, it's probably not going to lead to a good thing.